Let's get started. Welcome, everybody. I'm Guido Imbens from the GSB and the Economics Department. And on behalf of the organizers, welcome to this event on empirical work in the age of AI. We have a very packed schedule, and I only have 5 minutes for this introduction, given the fabulous lineup of speakers. But there's a couple of things I want to say. One is this got started when I had a coffee with Rose Tan, and she suggested she give a talk to the economics graduate students on how to use AI tools. Rose had done her PhD here and had been working at some of the tech companies. She was visiting here at Stanford for a couple of months. She felt the graduate students, and probably the faculty, some of the faculty as well, were not taking these tools seriously enough. And so she thought it would actually be good kind of to organize an event to get the students and everybody else kind of more focused on these things. So thanks to Rose for suggesting this. It got a little out of control in terms of the amount of interest, but thanks to Mike Tomz and Chris Fraga from IRIS, and also support from the Stanford Impact Lab, the Economics Department, and the GSB, here we are. All the potential speakers we approached were very enthusiastic about participating, and so we ended up with a great set of speakers and topics. In terms of logistics, given the schedule, we don't actually have a break, partly because with so many people here, we've worried that we would lose a huge amount of time. But so when people come and go, kind of please do so quietly. There is an hour scheduled for Q&A, and you can submit questions on poll everywhere, kind of using the QR code here on this slide. Now, onto the substance. Where is this all going? I don't know, and I hope to learn more. But clearly, this is not going to get settled today. This will be an ongoing process, but one that we should all be paying close attention to. Will the quality of research get better? I do think so, and we will see some compelling examples of that today, and some of the tools that will get us there. Will the quantity of research increase? Possibly, and that may actually strain the current publication process and require innovations to the process of reviewing and screening papers. Will the type of research and how we do the research be different? Yes, but exactly how, I think, is very hard to predict, and hopefully we'll learn some more about that today. So let me stop here and make sure we have time for the speakers, and Mike will introduce the first speaker. Thanks.
So I have been asked to give a live demo. Live demos are known for things going wrong. And fortunately today, when things go wrong, it's actually a great opportunity to show you what Claude can do. First of all, I'm curious how many people in this room already have Claude code installed already? Raise your hand. If we get about 90% plus, I will skip the first part. Perfect. OK, I think we are safe to skip it. I just want to flag one piece of this, which is, so here's Claude. It was installed. It took some time, so I did this in advance, but it's in the terminal. There's a lot of bash commands, and you may not know that cd, users dash rows dash documents dash whatever is what you need to do if you've never been in a terminal environment before. And one really easy trick is just, okay, well, if I don't know what I'm supposed to do, I can ask Claude to figure this out for me. And all I really need is Claude Code open up and some LLM, ChatGPT, Claude opened up, and I can just use one to get me the other. And so, for example, here I have a screenshot of okay, so here is my folder that I want Claude to open up, and I just drop this into ChatGPT, and I say, how do I open this folder in terminal? Because keep in mind here, you haven't opened Claude yet. So first you have to get to the folder, then you open Claude within that folder. And ChatGPT will just tell you. So a couple things I want to demo here is just one, it's very multimodal. Oftentimes a picture is worth 1,000 words, and it's easier just to send the LLM the picture rather than trying to describe it verbally. The second point I want to illustrate here is no question is too small for the LLM. This was a very simple question. I could have Googled it. And if there's one thing I want you to take away from my part of the talk today, it is ask the LLM. It is really just this one very simple thing. Okay, so we're going to try this interactive exercise in which every time I make this motion, you will say, ask the LLM. Okay, so we're going to try this. How did I figure out what terminal command to use to open the right folder for Claude? Great. And so this is really the only thing I want you to take away from my part today. A lot of the things that I will be showing you are actually anti-patterns of how to use this. Generally speaking, I'm switching screens now, so this is why this is happening. So while I switch, let's see here. Generally speaking, just opening up Claude and just being I guess I want to do some research. Can you help me do some research? It's not a good idea. And so I'll try to do my best to flag what is a pattern and what is an anti-pattern in terms of something to avoid. So we'll start with this quick framework for day-to-day usage. This is a model. All models are wrong. Some are useful. I hope this will be useful for us. Level 1 is just talking with an LLM, like ChatGPT, in a web interface. Number 2 is having either Claude Code, Codex, Cursor installed and using that. And level 3 is kind of using these specialized features like skills, MCP servers, CloudMD or AgentMD files. And then the fourth is adding in some lightweight engineering best practices to help your code base be scalable, be reproducible. And then the fifth one is having these really complicated multi-agent environments that are doing long-running tasks on their own. And as you move up this hierarchy, there's a lot more tooling complexity. The first one, all you need is really a web browser. And then the second, you need to install Claude Code. Money is another one as you move up. And you do need to pay $20 a month, or else you don't get access. Number 3 is getting some basic software engineering practices in, like GitHub, version control, and things like that. And then number 4, to have these multi-agents who are really running autonomously, you need at least a Claude Max plan. And with the recent changes, you may need even more than that. And so I kind of want to, for the purposes of this talk, we already kind of went through installing Claude Code. And then I want to talk about levels 3 and 4 here. I think anyone who can get to level 4 within enough time can get to level 5 on their own. OK, so this is the cursor. For my purposes here, cursor I'm just using as a file viewer. This is my Claude code. This is a brand new folder. There is nothing in this folder right now. You can tell that there is nothing because there is nothing in the cursor window. And now I've opened Claude in this folder. Now, the first time you open Claude, you may be like, well, I don't know what to say. And so you can just start with something really simple and say like, hey, I am a PhD student. Oh no, there's no internet connection. So we'll let it connect. While it's connecting, I'll let you know that like a lot of people have found it to be more efficient to talk to them verbally than to type. And so there are many tools out there that let you do this. And so I just hit a button, it lets me talk to it. I'm a PhD student at Stanford in economics. Show me some things that you can do. And so, you can fill it in with your own department. Maybe you are a faculty, a researcher, a graduate student in the political science department, whatever it may be. And it will just tell you what it can do. And this is really nice, because if you're starting with it, you may not know what it can do. For the purposes of our demonstration today, what I'm going to ask it to do is replicate this Allende paper, which if you're an econometrics student, you've probably heard it before. I will go ahead and get it started, and then as it's going, we can talk more about it. This is great. I am an econometrics student. I would like to do a simple replication of the Allende paper. Please make a plan for how to do this. Do not write any code. Ask me any questions you have. So when we're talking about patterns and anti-patterns, I think the first prompt I gave it, which is, hey, tell me some stuff you can do. That's good for exploratory work, but it's not really how you would want to be using it on a day-to-day basis. On a day-to-day basis, whenever you're starting a new project, a really good pattern is, hey, Claude, here's some stuff I want to do. Can you make a plan to do it? Don't write any code. Ask me questions. Now, in some ideal world, you would go write an extremely long and detailed and thorough and rigorous prompt. However, that's a lot of work. So we should ask the LLM to write the prompt, because it will be far more diligent and detailed than I would ever want to be, And so here it says, OK, great. Like, here is all this stuff, right? Here's a proposed plan. I do recommend you read the plan. This is where like an ounce of prevention is worth a pound of cure. I'm going to skim through it right now, an anti-pattern, right? But I'm just going to go with, yeah, fine, this all looks good. And so it has a few questions, and so I need to make a couple of decisions. For language, let's use Python. For sample, let's do the famous one. For comparison group, just do something simple. Output format, Markdown is fine. And then for depth, let's keep everything simple, and let's try to do this quickly. So typically, what you would want to do is not what I just said. You want something that is rigorous, replicable, and something that is, you're doing research here, right? One big bottleneck when doing these live demos is speed. And so, for example, I tried replicating another paper earlier this morning. It did a great job, but it was so slow. It took forever for it to go find the data, even though the data was available online. And now it has even more. I'm just going to go with the default suggestions. This all sounds good. Just make sure that whatever you're doing is quick. If something is slowing down, feel free to stop and ask me questions. And so, clearly you can tell I'm just asking it to focus on speed and go, go, go. That is not how you would want to do it. But a couple of important things here is just that you see this, collaboration between me and the agent, where it's like, OK, if you told me to go do this, I have these questions. For those in the room who have worked with RAs, it can feel a lot like that, right? Where you're like, go do X, and they're like, here's all my questions. And so it does feel like that type of dynamic a lot of times. One note here is a lot of times it's going to be trying to use commands that you may not be familiar with. An example one here is curl. And sometimes you may wonder, like, oh my gosh, is this command just going to erase everything on my laptop? Because that would not be good. And so security is always an issue when dealing with these. And so when you have a command and it wants to do this thing and you're not sure if it's safe or not, what should you do? Exactly. So you can either ask in here, you can pull up another one, you can, and that way you know that what you're doing is safe. There are safeguards built in. They have like prompt injection, protection, and things like that, but it's never going to be foolproof. And over time, it's also a good way to develop your own computer science skills. I think that they, even though LLMs can do everything, having some of that mental model in your head can be really valuable. So as you can tell, I'm basically just hitting enter. This is probably an anti-pattern. You should probably be reading some of this stuff. I have done this before this morning. I know it can do it if it just keeps trying. So I'm just like enter, 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 go, go, go. Let's see. So since it's going here, I want to show you what it has created. And so if you remember before, this was an empty folder. It may be more obvious. Let me just show the regular view in Finder. So these are it used to be an empty folder. Claude has found the information from online, downloaded it onto my laptop. For those of you who are in economics, not surprising, it was stored in a data file. It didn't have any trouble reading in this data file and converting everything it needed into Python. And then it created this markdown file as the output, which is what I asked it to do in the beginning. Yeah, I don't think the zoom is going to work that well there. I think this zoom works decently well. Can people see this? OK. So here, for example, is the write-up. This is the agent panel and cursor on the right. I'm going to close it because we're just using cursor as a file viewer today. And so this is a markdown file. If you do Command-Shift-V, it turns into something that's easier to read. And if you're an econ student in particular, you're like, I don't deal with markdown files. I really want things in tech. I want it to be a Beamer presentation. I want it to be things that are effectively like socially acceptable in my field. And so how do I transform this? Right. And so this is like transforming things from one type of thing to another is something that LLMs are exceptionally good at. This could be code from R to Python to Stata, vice versa. You can grab a R package, have it write a Python package out of it. It could be different types of content. No, this is good. Let's stop here. Can you create a LaTeX file? I want both a PDF and a Beamer template. It can take whatever piece of information and very, very quickly and very accurately transform it to whatever other format that you want. And so here, moving back into this folder, you'll be able to see it writing new files. So here it had some summary statistics and a CSV file, JSON file with the results. This is the Python file where it wrote a ton of code. Well, not a ton, 96 lines. That's not bad. And then these are the original. And so here it's now creating the tech files. So for those of you familiar, you've probably seen this type of thing before. And then I want to finish up by showing you a few of the components. I think that pretty much summarizes level 3. And I want to show you a few components from level 4, which are skills and MCP. I probably won't have time to go through MCP servers, but I'll do skills in the CloudMD file. OK, so first question. What is a skill? Yes. So just ask the LLM to make the skill for you, OK? So all right, this is great. I want to push this to GitHub. Can you please create a GitHub skill that will allow me to push everything with just one command? This is actually, yeah, no, this is, I think it will work. The key here is the connection to GitHub. That requires an authentication key, and so if it's not set up already, I would have to set it up. The skill can't do that for you because you actually have to log into GitHub and generate some stuff there. But in general, skills are just text files. And so they're usually hidden away. And so for example, here, yeah, again, this is an anti-pattern, right? Everything is just in one giant folder, and it's a mess. But once it creates the skill, I'll show you it. And it's just a text file. And skills are abilities that an LLM has that enables it to do specific things more in the way that you would like it, as opposed to whatever it wants to do. So it kind of like takes it from it can do whatever it wants to like, no, 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 no. This is like specific instructions for how I want you to do it. And I think future speakers will share all sorts of skills related to social science research. I think it'll be really valuable. OK, so it has created a skill. And I can't see this skill in this particular folder. And so, hey, you put this skill in a different folder. I actually want it in this live demo folder. And so if it doesn't do something you want it to do, you should just ask it to do the thing you want it to do. Usually it works. Sometimes it's gone really haywire, and the best thing to do usually there is I just completely restart a whole new session. So here now you can see the skill. It's in this .claude, which is actually a hidden file, so you won't be able to see it by default in the Finder. And then this is a skill that GitHub wrote. It says, hey, look, if you want to push everything to GitHub, this is how you want to do it. And then I can invoke this skill rather than dealing with GitHub commands on my own and typing them in. And so this is some skills you can invoke with a / command. And then the other thing I want to show you is the claudemd file. Great, so now you have a sense of what my preferences are. Please put all these preferences and ways I would like to work in a claude.md file. So whereas skills give the agent capabilities and specific instructions, the claude.md file is actually more of like, hey, this is how I would like to work. This is something that is probably going to be custom for every person. And so for example, here I had told it, look, I don't want you to put skills in this random folder. I like skills to go in this folder. And when I make a new project in the future, I would like Claude to remember that. And so the way to do that is to add it to this claudemd folder. And then when I create a new project, I can actually seed that project with the claudemd folder. And then it will instantly then know what my preferences are, so I don't have to tell it again in the future. So here's the claude.md folder. What it learned about me is I am a PhD student in economics. I like causal inference. I like for it to plan. I like for it to use Python and LaTeX and these things, right? And so over time, it can grow into a very large file that can help you jumpstart future projects. And so this is where these things are building on itself. And over time, you can really accelerate your efficiency through the agents being able to learn from session to session. Let's go back to the framework. So we have covered claudemd files, skills. We covered a little GitHub, a little bit, and IDEs, cursors, and IDE. I want to show you some things that might be helpful for you that you may not think about that LLMs are really good at. So the main one is building a UI. I have no idea how to build a UI. I've never coded a UI by hand manually. But agents are insanely good at this. And so usually when I do research in grad school, I would never code up a UI just for fun, because that's a ton of work for something that's probably not that useful. However, agents lower the cost of doing this work. And so please build a UI for some of the Lalonde results. I want to be able to interact with it. The internet is gone. That is one issue Claude cannot fix because it must be attached to the internet. Build a UI for the Lalonde results. I want to be able to interact with it. And so, for example, you can think of interactive tables. You can build UIs that let you, maybe you have like 10,000 different graphs. You could build a UI where you have every graph and you just click check marks for whichever graphs you want to select. There's a lot of different ways. And so just pick something and make it simple. An anti-pattern, right? Like ideally, you should have opinions on these things. I generally, with UIs, have not too many opinions, and I want to try to make sure we're keeping within time here. And so it says here, OK, I'll default to Streamlit, which seems perfectly reasonable. If you want it to do some other way of having a UI, that's fine too. You could have just an HTML page. There's a lot of different ways to do this, and I think I will flag one thing, since you are a group of PhD students. So I think that PhD students tend to think a lot and then do. And with LLMs, it's often easier to do and then think, because doing is so cheap now. And then a lot of times you do the thing and you realize this is not what I thought it would be. And so, for example, with building a UI, you could imagine going online and looking at, oh, what's the best UI that I could possibly come up with? Or you could have like a back and forth, 100-thread exchange with Claude about what's the best, computer science stack to use to build a UI. And generally speaking, I think it's better to just try it out and then iterate, right? Another inclination you may have is, let me go read about LLMs and how the model works and listen to all of Andrej Karpathy's videos before I start using Claude Code, right? And that all makes sense. But I think with these types of tools, if you had 20 hours, it's better to just spend 20 hours interacting with it, and you'll learn that way rather than 20 hours thinking about it or learning the theory. OK, so here it's like, oh, look, it's running in the local host. You should just do it. But I don't see anything on my screen, and so what should I do? Yeah. Like, OK, open this. So here's the app that it generated. And by the way, all of this stuff may very well be not correct for those of you who know Lalonde. So I'm not guaranteeing correctness. I did not do any auditing or validation, and I moved through this way too fast. But my point is, here's a UI, and I can kind of select different covariates to use, and it'll change the estimates. I can reset, I can do different estimators. These are things that before LLMs we may never really think to do with research that now just become so cheap and easy. And so going back here, you'll see it created all this stuff in here for the UI as well. And so, yeah, I hope that's helpful. I think you know my main message from today, which is thank you. And you can really do it for any question, big or small.
Thank you so much, Rose. This is working now? Yes? Great. Our second presenter is Yiqing Xu. He's an associate professor of political science at Stanford. His research focuses on statistical methods and, in particular, causal inference with panel data. And he also does research on comparative politics with a focus on China. He's joining us remotely from JFK Airport in New York. So this is another live demo. We'll make sure that this works. He is going to share the AI-assisted workflows that he's been using to reproduce empirical work and to develop statistical software. Hi, Yiqing.
Hello, everyone. Can you see me well? Yeah. I actually cannot see myself, so my face must be super large in the room. So I will talk about two or three AI workflows. First of all, let me thank Mike and Guido for organizing this. Thanks Rose for its great demo and having this great idea. I saw a Twitter 3 days ago that they say Twitter is a group therapy where nobody gets better. So I hope I hope this is a group therapy that we actually learn from each other and also feel slightly better afterwards. All right, so let me try to move my screen. All right, so I think as you've tried that this agentic AI with Cloud Code and Codex is to me it's another ChatGPT moment, probably bigger than ChatGPT. That also makes us sleep deprived because it's both so exciting and creates a lot of stress. But I think by trying more, the stress level will remain high but stabilize. That's what I think. The skills, as Rose described, is to me it's like a structured user and system prompts. You can actually see those markdown files, and they will be attached to specific tasks that you ask LLM to do. And I think the key to the power of this skill files is that it's essentially solve the context window issue, right? So you probably have experience of conversing with ChatGPT in the chatbot, and as you talk more and have more and more rounds of conversations, it gets slower and slower because the context window grows. But skills breaks it down, agentic workflow breaks it down. So every time you have a specific task, you don't need to so that the system does not need to attach everything before to the and send it to LLM, which makes it super scalable. So it's basically, as you've just seen, that from ChatGPT or other large language models being able to answer better questions to do things for you using various kind of tools. So the workflow I want to demonstrate a little bit and especially reflect on are three things. One is a large scale replication workflow I was working on since February, and the other one is a workflow that I try to maintain and create packages for myself and also maybe can help others. The last one is my own thoughts, maybe tips on building your own workflow, because I think as you just saw, you've just seen from Rose's demonstration that we will have to build our own workflow that is customized to our own needs. All right. So I think these three workflows have some commonality, which is they're structured, they're verifiable. I think the LLM or agentic workflow works the best when it can actually actively and real time check answers and correct themselves. And hopefully it's also not idiosyncratic, it's iterative and it's repetitive. So I've tried to use OpenClaw as well, but I don't find it very useful. I stopped using it because our job, it turns out, is very idiosyncratic and very complex. But some elements of our job are repetitive and maybe can be automated with more efficiency. So the Gentzkow and the replication are two examples. All right, so the first on replications. In the past few years, actually, Mike says I'm an associate professor, not associate professor until July 1st, but fortunately I passed that hurdle right now. But before that, I've been working on several large-scale replication papers. So the reason why I replicate those papers from like 20 papers to 70 papers is because I want to understand how relevant new methodological statistical methods are to our empirical applications. Right? Some of these methods are invented by other people. Some of the methods I'm involved. I want to understand whether they matter, right? And the other reason is because only when you start to show and make a difference, people pay attention and you can improve practice. That's why I was trying to do this. I think this kind of work it was valued in the field, which I'm very thankful. But with AI, now I start to question the value of this type of work, right? Because it's now so much easier to do. So I want to make my old self obsolete as soon as possible so that I can move on to more exciting stuff and maybe focus more methodological innovation instead of just replication. You've seen what one replication from Lalonde, but I can tell you that in order to do good research, two things are important. One thing is that you want a very high level of accuracy, right? Maybe 99% and address the last 1%. The other is that if you want to replicate other people's code, as human, you probably have done that. It's very painful. Lalonde is one of the examples where data are very well curated on GitHub, and you can directly get Lalonde data from our package. But other data, if you just directly download from ICPSR or AEA archive or Harvard Dataverse, it's very heterogeneous, right? You have Stata, Python, R, and people have different type of coding habits. And working on each of these projects, the most of the time I can tell you is spent on harmonizing those packages, those replication packages, so that we can apply a template to those packages and then better the methodological innovation or existing problems in the practices. Okay, so then with my collaborator and former student and Leo, and we built this workflow, which is fairly sophisticated right now. This is version 2. We have version 3 right now. So you can think of them as a 3-layer system. What I learned from this process is that you actually, in order to do good scientific research, you actually want to minimize the LLM involvement. Right? We want to ask LLM to teach us skills, which is totally legit. But LLM will, because of the probabilistic nature of such models, if you want to have it reproduce stuff, you want to have version controlled deterministic code, which are a bunch of Python files, right? So you can think of LLM in this workflow to play 2 roles. One role is to semantically understand this paper. In order to reproduce paper end to end, you give a PDF and then it extracts a replication material and start to run code. First, the LLM needs to understand the paper, right? Understand which number corresponds to what quantity. The other is that LLM needs to play a role of software developer to update those deterministic code. Then next morning, you close your conversation, that these code, because they're version controlled on GitHub, still can produce the same results as you seen last night. What's really interesting in this pattern, it is like a 3-layer system, is that in the second layer is actually knowledge accumulation layer, where a bunch of markdown files are the skills, right? Skills are just markdown files that accumulate various kinds of weird cases it has seen in those replication packages. And you can see them. After seeing those markdown files, I don't think this is humanly possible to do reproduction or replication in large scale. You can do like 70 papers, 100 papers maybe with a large team. I4R did the hundreds of papers with 200 co-authors involved, or maybe more. But if you want to have AI workflow to scale it up, if you want yourself to scale it up, you have to rely on AI. And it's perfect for AI because the results are verified. Just to show you, give you some sense that we are able to reproduce regression tables in almost like 400 papers now. And this, we randomly draw 384 papers from all the PolySci top 3 journals since 2010. And this pattern is very interesting. It's also documented in the recent Nature paper, which shows that because of a major data archival requirement and verification requirement pushed by a bunch of PolySci journal editors, the reproducibility shown by these green bars increased dramatically. But this green bar actually involves a lot of work, because for each paper, we dig into the replication files, we run them, harmonize the code, we match the numbers with the numbers returned by the software. It's the heterogeneity that makes this job really hard. If all the code are written by AI in the future, it actually will be much easier. It is human element that makes this job more difficult. So another thing that I find it may potentially change methodological research is the abundance, or in the near future, very near future, the abundance of harmonized replication file, harmonized data sets, right? We know in the CS we have a lot of the standard data sets, which greatly accelerate CS research like ImageNet. But because of this kind of workflow, I think we will be able to acquire more and more such data sets. This is a paper on the left. This is a pattern that after replicating 67 papers for 4 years, published. I was very fortunate to be able to publish this paper before AI. So where this shows on the bottom left is that, interestingly, you see there is a discrepancy or difference between two-state least square and OS estimate. And this discrepancy, this ratio is decreasing with the first stage strength captured by rho. This is first stage correlation coefficient. And this is not theoretically expected. And actually, experimentally generated IV, you don't see that. So our interpretation, which is also documented elsewhere, is that it's because IV is a ratio, because you have unconfoundness and or exclusion restriction violations, such bias will be amplified by the first stage. That's what we documented, and we want to show this to researchers to give them caution, right? And this took us 4 years to do, and we did this with the pipeline, and this took us 3 days to extend the sample to 92 papers with 200 specifications, very similar patterns, but much, much smaller human labor involved. So I think we can do such work at scale much more easily with AI. The second thing is another, I'm thinking about how to replace my old self, right, to do more exciting work. Another key bottleneck for my workflow is maintaining and developing packages. So I and my collaborators maintain over 10 packages. Like some of them are R, some of them is data, which is dying, I think, and some of them are Python. The reason why I'm not very optimistic about data is because I think it's not very AI native. It's closed source. AI cannot learn very well, and you can use a MCP, but it's a bit complicated. But how to maintain and develop such packages at scale? That's the question I want to address, right? Of course, we know Claude or Codex, you're just very good software developer. Well, it should be a very simple problem, right? And I think there's another thing that is, but most of the training data is on software development, not particularly on development of statistical routines. But what's nice about statistics is that oftentimes we have proofs. We know the properties of this estimator, and we know what should be expected, right? And we can take advantage of that. So then the simple idea that I have is that maybe we can spawn agents independently with distinct set of informations. The builder, the agent that actually builds the package, does not know the true parameters that simulator gives to the data. And the tester, which is essentially deterministic code, empowered by AI to check whether the package built by, or the routine built by the builder actually can return an estimate that is close enough to the DGP that only the simulator knows. This turns out to be very powerful, extremely simple idea, as shown here. I think this will be absorbed very quickly by those large language models because they are agentic, right? So it's a very simple idea. Probably next version, you don't even need to have this particular workflow. By the way, this is now a Claude plugin with one line code in Claude, or you can ask Claude how to install it. Look at this website. One line code, you can have all these agents set up in your workflow to write packages for you. So whenever it doesn't have to be a package, it can be a set of structured code for your empirical project as well. All right, so we tested, we documented a couple of examples in the archive paper, but I actually tried it for a real application, right? So what we did is we wrote this paper with, I wrote this paper with my colleagues, Avi and Jens. We already had a prototype by my colleagues. So I just made this package with this particular workflow, that's Claude, with a few shots. The first shot is already very good. Again, as Rose mentioned, that you want to discuss the plan with quite thoroughly, maybe have a conversation with the AI to plan it out, and then it will automatically create hundreds of tests to guardrail this entire process. And then it takes like 1 hour, And then the next round is much faster. The next round is about visualization. So it's already online. You can check it out. So I think this bottleneck of maintaining and developing packages is no longer a bottleneck. It will be very, very cheap to do because it's simply software development, right? And what's empowering is that now without much resources, as an individual researcher or a small team of researchers, you can do this very cheaply. You don't need to even hire people or spend too much time on this. And then we can focus our time on more interesting important problems. All right. So lastly, if I have time, and I cannot see the clock, I also want to share some thoughts or maybe tips on building your own workflow because I'm involved in building these two workflows, which are fairly complicated. Also want to automate other parts of my work as like check, validate my citations or taking notes or things like that. You will have your own application because everybody habits is different, right? First of all, as I said, there's no one size fits all. I think the best way, I find the most comfortable way is to do my own work as usual, but try to replace tasks one by one. So you can learn from the internet. You can try to build skills or directly import skills from people on Twitter or on GitHub. Usually the rule of thumb is that if this is a task that is useful for computer scientists or for business people, it's already there, but the skill is already there. For example, digesting a PDF into Markdown, into TXT file. There must be a skill that's very well written, it's already there and proven to be working. But however, our job as researchers, Stanford researchers especially, are quite idiosyncratic and complex in a good way. So my feeling is that oftentimes the ingesting cost, right, to try to make other people's skill files work for you is actually much bigger than developing the skill yourself. So what I do is basically start from a painful task, and then after a few rounds of like a few dozen rounds of conversations, ask AI to reflect on what we have achieved. All right. So in this session, and then ask it whether worth it to make a skill. If it's too idiosyncratic, maybe not worth it to make a skill, and then it will give you, their thoughts. I don't know which pronoun we should use to describe AI. And then we can iterate. But gradually, after you've done with a few tasks over a month, you will have a pretty structured and usable workflow for your own. All right. Okay. So I think most people should start with the $20 version of Cloud Code Codex. Each one is fine. I don't. Codex is also very capable. And if you hit rate limit, we will very quickly hit rate limit. I think there are $100 worth every penny right now. I know $100 is expensive for students. I think the departments or institutions or university need to think about how to provide institutional support for students. But I think it works for every penny. Right now, it's heavily subsidized. People have made calculations. The estimates vary. Some people say the $200 version actually equivalently means like $2,000 to $5,000 of token, depending on the hour of you do your work. Yeah, but you will be able to create your workflow, and you don't have to rush, right? Today you have a task, try to have AI to be part of it, and then make a skill. And tomorrow you have another task, and gradually you will be able to make it. Another thing I found very interesting, I'm not sure how many of you are already encountered this problem, is that what to be shared, what is your own, right? Oftentimes we work with collaborators. What should be shared and what should be GitHub, what should be put into Dropbox. I know there is a cloud version. You can put everything on cloud in Claude, but that version doesn't work for me because I cannot see the file structure very transparently. And also because it uses Ubuntu, it's fairly lag behind on certain packages like in R or Python, it's a little bit lag behind. So I don't like to use their cloud system to do this. So what I do is everything is local, but I use GitHub and Dropbox to sync the files and share the files. So I think this works for me. Maybe there will be other better plans in the future. So I will have a personal AI brain. That is my main workflow. But for Gentzkow, it becomes public, it becomes open source. So I basically make it a plugin. Now I can directly plug in that workflow into my AI brain. But most people will have their own workflow, and that is a private repo unless you want to share everything with the world. You can make it public on GitHub. And these are mostly what computer scientists call plain text, right? Those are the markdown files. Those are some of the Python codes. Those are the Cloud MD, and they're easy to maintain using GitHub. And you will also have a lot of binaries, like slides, data. Those are not suitable for Dropbox, for GitHub, right? Because those files are large and they're not plain text. And you also may want to share with your co-authors, right? So I will put these into Dropbox folder and then use Symlink to establish a link to your workspace, because cloud mostly work in the first personal workspace, which is your AI brain. And this Symlink, you can ask Claude what Symlink is. It's essentially a mapping from the folder in the Dropbox that is synced through Dropbox to your own workspace, which is where your AI brain lives. And same thing for Overleaf. Overleaf essentially is a GitHub system in disguise. Every Overleaf folder can be Git, right? Git maintained. It's version controlled. You can pull and push, coordinate with your co-author. That's what I do with my co-authors. And also, if you have code projects, if those codes are mostly plain text, right? You can also use GitHub public or private repo and then symlink to your workspace. That works for me. Maybe in 2 weeks things will change, but this addressed the problem of sharing data with my collaborators. This also addressed the problem of changing computers. I go home, I don't carry my laptop back home. In my home computer, I just pull everything from GitHub or Dropbox or automatically sync. Then everything will be ready. And the conversation will change, right? The AI will write left handoff as a markdown file to give it to the next AI, which is same model but different conversation. So there's no short-term memory. The memory is transferred through these markdown files. Okay, last thing, the AI burnout is real. I feel it firsthand. I personally have 3 sources of anxiety. Right, first you will feel behind. It's stressful, and because the field moves so fast on a weekly basis, maybe daily basis, like Cloud pushing out so many products on daily basis. So is OpenAI and Google. You also question the meaning of your work, past, current, and future. Right? That's I question the value of my work. So that's why I want to make my old self obsolete, and I can move on to new things. And you also feel overly stimulated, right? Because it is so powerful, give you so much positive feedback. I even start to develop withdrawal effect if I don't use it. So I think we need to take care of ourselves. It's very real. At least for me, it's very real. My current answer, I talked a lot with my CS colleagues. Some of them are even more pessimistic than I am. The current answer is, one is that there's a long tail of scientific inquiry, especially in social science, maybe also in sciences, that AI or those AI companies are not focusing on. And AI right now expands what's doable for us. So for the next few years, I don't know about 5 years later, but maybe for the next 2 or 3 years, there's a lot new problem that we can solve. But before this, we cannot solve. 2 months ago, we cannot solve. And another thing is that this may be a little bit pessimistic, that even AI can do our job better than we can. I think the pursuit of knowledge itself is very rewarding. Just like Go players, knowing they cannot beat AlphaGo. There's no way, but they still play Go for fun, and they actually actively learn from AlphaGo. That's a little bit pessimistic, but maybe the pursuit of knowledge in itself is very exciting. All right. Anyway, so I think Guido is right. I completely agree with him that the tsunami is already here. It's not 3 days later. It's already here. We can do fantastic things, and if you don't, other people will do fantastic things. We have to adapt, and we as a community need to think about how to evaluate good work, how to do good work in the first place. And another thing is that as a teacher, I'm thinking about how to prevent skill atrophy, and also for myself, right? So now it's very hard to work without AI. So I think for producing research work, it would be ridiculous or even malpractice not to use AI, right? Just like person in this picture. But also, I think we need to keep training ourselves even with resistance without AI. Otherwise, we will lose our functionalities as humans. All right, that's all I have. Thank you.
Yiqing, hello? This might be off again. Yiqing, thanks very much for that presentation. I'm glad to have you in the political science department as my personal AI trainer. Come to you for questions. It's my pleasure to introduce our third presenter. That's Matthew Gentzkow. Matt is the Landau Professor of Technology and the Economy in the Department of Economics at Stanford. He's also the Faculty Director of Stanford Impact Labs. His research focuses on the economics of media and technology industries and how those industries affect democracy and civil society. Matt will be sharing some practical advice for the PhD students in the room, especially about how to be a PhD student and what to learn in the age of AI. Thanks, Mike.
Well, thank you everybody for coming out. Thanks to Guido, to Mike, who everybody's part of organizing this. I'm just incredibly glad we're doing it because it seems really fun, really important. I am in some sense like the last person who should be up here talking to you in terms of, how close am I to the technological frontier of adopting AI in my workflow? Not that close. Like some people in this room may be desperately racing to catch up, and I don't have any particular knowledge or expertise that is necessarily any better than yours. Also, kind of prognosticating about the future is something that I generally avoid studiously and don't consider myself to have any particular skill in. But I thought at this time, just given how interesting all of this is and where we're all sitting, I would try to share some thoughts, just sort of like putting myself back in the mindset of being a PhD student, thinking about what it is to be a PhD student right in this moment, and some kind of thoughts that have occurred to me and as I think about that. So free disposal, but this is just kind of my musings for PhD students thinking about AI right now. And I would start a little bit where Yiqing left off. I think like there's a lot of uncertainty right now. There's a lot of change. There's a lot of anxiety. There's like, are we all just going to be engaged in something that is kind of playing Go for fun? Even though the robots do it better than we are, what does that mean for your futures, your careers, your economic prospects? And so I think all of that anxiety is real, and we need to kind of be aware of that. I would also go out on a limb and say I think this is probably the most exciting moment ever to be a Stanford PhD student in the social sciences. And I use the word exciting here and not necessarily like easy or comfortable or, there is a lot of uncertainty, there's a lot of anxiety, but I think the potential for both what you can achieve in your career and the impact you can have on the world right now is larger than it's ever been before. Certainly the right tail of what the most creative and talented students in this room can achieve, are going to achieve, all of you. That's why I put Stanford here instead of just PhD student. That's just like a stand-in for especially talented and creative, which is all of you. Okay, so maybe this is kind of a crazy thing to say these days. Why do I say this? Well, let me just make a couple of observations. So one, I think it's really important in this kind of, like we've been doing a lot of tactical stuff here, which is super important. Like you were trying to replicate Bob Lalonde's paper. How do you do that efficiently? And those details, what do you do every day? How do you make your workflow better? How do you get AI agents to read your email for you? That's all super important. But I think it's also a really important moment to kind of zoom out and think about what we're doing. And if the whole broad purpose of this enterprise is meant to be addressing important challenges and needs in society and making people's lives better, I do not think there's any credible argument that we no longer need to worry about that that's no longer an important enterprise. There's like a very long list of questions that are the questions that people in this room and our colleagues all study that are more important, more critical than they've ever been before, and where the need among policymakers, among decision makers, among private firms for credible, reliable, high quality science to guide those decisions, to help them figure out what to do, to help us figure out what to do, to help us solve these problems is bigger than it's ever been before. I don't see any problem of lack of need for the enterprise of social science in the world right now, and I think that's going to remain true even as AI accelerates. Second thing is, if we have all of that need, the tools, the firepower that you guys are all learning, building, developing to address those needs is growing exponentially. So whatever, if I went to grad school and thought about how is this social science stuff that I am learning potentially going to address problems in the world, the tools that I had as a graduate student to do that were exponentially less powerful than the tools that you have already and that you will have as you go through grad school and go through the next phases of your career. And so I think one general theme I have in thinking about this is as the power of the tools we have and our ability to do stuff grows, the importance and return to thinking about what we are doing with it and why goes up. So if you have a really, really powerful thing you're pointing, the coefficient on how does social utility change or how do your career prospects change if you point it in the right place and the wrong place gets really big. And that pointing of the firepower, we might say like, well, there's still nothing for us to do because the AI will figure out where to point all that firepower, how do we use all these tools, how do we make the world a better place? That may be true at some point. But I think in some relevant medium term here that I believe is going to last for a while, in order to deploy that power effectively, we are going to need smart, innovative, creative humans to do that. And that's going to be you guys. Plus, on top of everything else, this work is just getting a lot more fun. I have not heard a lot of people in the rest of my career talk about withdrawal from the fun experience of like writing R code or something. That was right. That was not part of the thing so much before. And I think it's like very real. You watch Rose up here, like chatting with Claude, voice commands, like, oh yeah, why don't we just like fix all that stuff? Yeah, I'm busy. Could you just figure it out for me? Like, it's like a completely different experience of what the minute-to-minute, day-to-day of research is like. It's like pretty fun. I find it really fun. So, that's not so bad. Okay, so with that kind of introduction, let me just talk about a few things. One, maybe give you like a little more of justification for why do I say I think deploying all this firepower to address social needs and social problems is going to require humans, at least for a good long while. Second, if I was a PhD student today thinking about what kind of human capital to invest in, what might I be thinking about? What are the kinds of human capital that are likely to remain really valuable in the future or to get more valuable in the future versus things that may be less so? And then I'll end by summarizing that just with a little bit of advice. Okay, so why do we need humans now and for some time? Just like a few different thoughts that feed into that for me. So, we're in this world where everything seems to be changing super, super fast, and just extrapolating things out, it just feels like what are any of us going to be doing? If we extrapolate this trend out for 6 months or a year, 3 years, 5 years, like what are any of us going to be doing? So obviously computer power, the capability of these models are changing incredibly fast. Just the whole economy is changing very fast in terms of pointing resources, giving people subscriptions to Claude Code that have a marginal cost of $2,000, $5,000 a month and selling them for $200. Like we're devoting tremendous social resources to this. And the frontier ways of working are changing really, really fast. So if you just, aren't we just going to like quickly converge to utopia, solve all our social problems, robots will be in charge of everything. They might like eat us and destroy the world too, but in the optimistic scenario, they'll be in charge of everything. We'll have this utopia. Like, why are we not going to just follow this trend line out and extrapolate them? Well, because there is a bunch of stuff in the world, even in the best case scenario where we have perfectly well-meaning, super, super capable AI, that changes really slowly. And that tends to be stuff that involves humans in inherent kind of fundamental ways. So human behavior broadly changes slowly. Some of it's changing pretty quickly in relative terms these days, but it does not change at the speed of OpenAI model releases. Laws and policies, like there's a bunch of stuff right now in the world that says such and such a thing must be done by a human, for example. Like AIs cannot testify in court cases. And all of the policy structure changes slowly. Institutional structures change slowly. Firms and firm organizations change slowly. Incidentally, disciplinary norms change slowly. So one of the interesting things kicking around is like, what are incentives for careers, and how are we going to evaluate tenure, and how are we going to evaluate graduate students, and how are universities and the way they're organized and the departments and all that stuff going to change? Again, all those things are going to change, but are going to change slowly. They're not going to change at the pace of AI companies. So all this means there's going to be a lot of stuff that evolves slowly. And interestingly, many of the most important social problems that we were talking about depend on these things, on the slow kind of things. For the foreseeable future, the humans are mainly the ones in control of and impacting those slow things. And if you go right now and tell Claude, please improve food safety laws in Japan, that's like a pretty hard problem for Claude. It might think of some good ideas about how to improve food safety laws in Japan, but actually improving food safety laws in Japan is not something that Claude is going to be very good at. Why? Because that change requires societal change, requires policy change, requires convincing people, requires communicating. And in many of these cases, it's not even just that like one person needs to change, but you have to have coordinated change among many people. Okay. That's one thought. Just kind of frictions that are slowing things down. Second is, I think particularly when we're thinking about social science that's pointed in some fairly direct way at trying to improve something in the world, in order to do that work still today and for the foreseeable future, critical parts of it depend on interacting with human beings. So thus far, robots on their own do not have a lot of success in like figuring out how to get some company to give you really interesting proprietary data that they otherwise wouldn't give you. That is something which is like a key input to many, many of the most influential research papers kicking around, right? Claude would not do a good job, say, beginning to end, please write a paper where a key part of the paper is you went into a middle school classroom and did an RCT where you had the kids use different kinds of math curricula, right? Claude's right now would have a hard time finding subjects for brain imaging experiments, doing field work in development, interacting with governments, building partnerships outside the university to do work in various ways, translating research. When you found something that works, how do you communicate it? How do you get it widely adopted? All of this is stuff that I think falls in this slow category and that humans play a critical role in. Third, as I was sort of alluding to, I think in a lot of ways, the big existential question for all of us is where are we going to point all of this firepower? And that pointing is something that I think if we want to do it well, that there's a kind of fundamental human element to doing that. And not actually to say that, I think actually one of the interesting things about AI and one of the important things for us to remember is that we want to make sure to be using it not only in these like downstream tactical things, but also in the part of our workflow that is ideation about big picture, what questions are we asking and why, and what research might be important. Like AI can also be really helpful with that. But I think at a high level, the sort of why of all of your research is something that involves understanding and weighing human values, institutions, perspectives, norms, and a lot of stuff that is not right now the comparative advantage of AI models. in addition, thinking a little more concretely about these objectives, I think there's an interesting, there's an interesting dichotomy that we've seen for a long time, even before AI, with like old-fashioned machine learning, that like computers are especially good at things where the thing you're trying to maximize is quantifiable and measurable in real time. Because then you just turn the thing loose and it can just hit that optimization problem and do really, really well. Why is write a really convincing quasi-experimental, natural experimental study of the returns to education not in that category? So things in that category are like playing chess. Because if I play chess, I know whether I won. Folding proteins, if I got it right, I know when I got it right. Why is a really convincing estimate of the returns to education not in that category? It's because, at least given the typical methods we use, what constitutes a convincing paper, whether Guido's IV or my IV or somebody else's diff and diff or somebody else's regression discontinuity or regression or whatever is convincing or not, depends on the priors of the audience and has a kind of deeply subjective, right now, element in evaluating it. Audiences have to evaluate, do I find your supporting evidence, your story for why this is convincing, compelling? There's lots of more automated stuff we can do to validate and support these things, but these kind of things, I think, so far involve that like people's priors are intimately bound up in this, as Jesse Shapiro and Isaiah Andrews have talked about and written about. I think one of the important ways we can think about the role of science is speaking not just like in a decision problem to a single decision maker, but communicating in a way that humans with heterogeneous priors and different beliefs about the world can learn from the evidence, see the evidence, make sense of it. And so I think all of that has an inherent human component to it too. Okay, so none of this is, I don't want to be the guy who's like, there are certain things in the world that are essentially human and AI will never be able to do. I kind of the belief, if we go out far enough, it's all fair game. But in the medium term, I think there's going to be demand for the kind of capabilities and skills that you all are building. Now, within that, which kinds of capabilities and skills will be valuable? I think to the kind of main theme of this whole workshop, the obvious one that we're all talking about is what you should really be investing in first and foremost is using these tools efficiently, creatively, effectively. I think there should be 0 people in this room who are not devoting substantial time and effort to doing that. I don't think there's any great analogy for this change because we've never been in a change like this, but I think a reasonable kind of lower bound or maybe rough approximation to the magnitude of the change we're talking about is think about how social sciences changed before we had pretty fast computers, 1970, 1980, 1990, something like that, versus before. And that kind of transformation, I think, is broadly analogous in order of magnitude, in my best guess, to the one that we're going to face. Maybe it's less than the one we're going to face. But so if you think about, if you were coming into social science in 1990, would you want to spend a fair bit of time learning how to use computers well? The answer is clearly yes. And I think that we can think a lot about how do we use these tools to write the same kinds of papers we've been writing better. And we're going to write a lot more of those papers faster. But I think for sure, just like in the era of computers, what's really going to be most innovative and important and impactful and what's going to drive the most successful careers is people figuring out what are the kinds of papers that we can write now that we couldn't write before. What are the kinds of questions we can ask now that we couldn't ask before? This is all about creativity and innovation. And a good thing for you all is you think, who tends to be good at creativity and innovation? It's like young people. And so you all are very well positioned in ways that I'm not, that Guido's not, others are not, to figure this out. Second thing I think is is, maybe Guido is actually, but I'm not. Yeah, so second thing, related to what we've been saying, I think the return has always been high in our disciplines to being able to ask good questions. I often tell my students that figuring out how to evaluate what is a good question, what is a good research idea, what is a good research proposal, how do you sort of solve the dynamic programming problem of, okay, I have these 5 things I'm working on, which of them is more valuable, where should I allocate my next effort, my next hour? Like, that is the most important, it's the hardest thing you learn in grad school, it's the most important thing you learn in grad school, it's probably the thing we teach the least well. All the other stuff, like take some econometrics classes and learn how to do this or that regression, like everybody can do that just fine. This is the hard thing, and I think that has always had a high return, and I think that return just gets even bigger now. So as the power of these tools grows, the return to pointing them in the right direction gets high. Guido alluded to what is happening at journals. I'm right now the editor of one of the American Economic Association journals, and we have regular conference calls right now talking about how are we going to change the editorial process for the AER and ARI and all these journals in a world where our number of submissions may go through the roof, where the tax just on editors and trying to handle those things may go through the roof. What are we going to do in a world where the production costs of like plausible looking research go way down? And I think what's kind of obvious is as the quantity gets really high, the value of the thing that becomes really scarce is being able to evaluate and discriminate and figure out what is the work that is most important, most credible, most well executed. And that is something that I think for the journals is really hard. I think it makes us think hard about what is the criterion. But I think for you all, that means that categories of work where the answer to the question, why was this important, are as tangible and objective and clear as possible. Like this thing, in fact, told us something that we really need to know for the world. We were trying to figure out whether we should have voter ID laws or not have voter ID laws, or we're trying to figure out how to teach kids math, and we just learned how to teach kids math better. That kind of stuff is going to have big return. Research in the category of, this is mainly interesting because I solved a really hard problem, or mainly interesting in the sense of, I came up with a really clever natural experiment that estimated a parameter, and we're not quite sure what the parameter is good for, but someday we might be interested to know it. The price on that kind of research, I think, is going to go down. Okay. Third, since a lot of the stuff that's going to slow us down is about humans, people who are really good at working well with other humans are going to do well. Relationships, intuition, emotional intelligence, ability to work in teams. I think the return to all of these things goes up, and they remain essential for all kinds of different steps, including doing the research, communicating the research, and I think like the emotional intelligence of and ability to form relationships with other people. Like the robots are making gains in this, but I think we're going to beat them for at least a while. Fourth, so I put here being a good CEO. I often talk about, to students and others, I think academia is most like entrepreneurship in what we're doing. I mean, that's a thing that it's very much like. Being a grad student is sort of like being some founder, in a garage, and you like do all this stuff by yourself. And as you kind of go up, the scope and scale of what you can do grows. And like my job is a little bit more like running some small startup with a team of 10 people and trying to figure out how these things work. Now, something that is just like so striking and cool in watching these workflows and in using agentic AI and thinking about how it works is what we are doing looks more and more like management. Yiqing has in his workflow, there's like a janitor, and there's a builder, and there's a checker, and you have to remind the janitor to come in after the checker to clean things up. And questions about how do you organize projects, manage projects, how do you deploy those resources effectively, all this stuff becomes more and more important, as does this kind of like high-scale design, strategic thinking about where it's all going, long-range vision. So I think the kind of management skills become more important. Finally, trust is going to be really scarce. In a world where there's an enormous volume of stuff produced, And then there are people and institutions that have to make critical decisions. Figuring out who they can trust on, rely on, is going to be really hard. A school district needs to do something, the president needs to do something, a journalist is trying to write about something, and there's a whole flood of AI-assisted papers out there with all kinds of different answers. Who are they going to turn to? How are they going to evaluate individual universities, institutions, individual researchers who have reputations for credible, reliable, high-quality research are going to do really well in that world. So to end, just kind of summarizing all this in a bit of advice. One, as we said, you should be aggressively learning, experimenting. I love the thing of just start today and start each day with doing some more stuff. And before you know it, you're off and going. Think really hard about why we are doing this. And if your answer to that question is pretty loose and pretty fuzzy and sort of like, well, I kind of liked solving problems when I was in undergrad, and it seemed like it would be fun to keep doing that, that's fine. But this might be a good time to kind of go beyond that and think, you now find yourself positioned to perhaps solve some of the most important and big social problems in the world. Even if that's how you got here to begin with, maybe more focus in the why of your work will help you. Investing in human stuff, take yourself to business school in the sense that I actually think that like concrete stuff about management and how do we run organizations is going to be really tangibly valuable in thinking about AI workflows and how to run your, on the other slide, I didn't say it out loud, but like you're going to get a promotion. So that you grad students used to be the guy tinkering in the garage, you're now running a firm with like 100 people in it. So how do you run a firm with 100 people in it? Well, people have actually thought about that some. And they teach it over here. So learn some of that. Take a deep breath. It's crazy, it's scary, but it's also super fun. And the last thing, so that's it for advice. The last thing I'll say, just so as Mike mentioned, in addition to being a professor in the economics department, I'm also the faculty director of Stanford Impact Labs. And so along with Iris and others on this campus, we're all thinking about how to support and accelerate this transition, make it happen efficiently. So I wanted to let you know about a pilot project that we are designing. This is not an official release of this yet, but we are hoping to launch on July 1st what we're calling a fast grant program at Stanford Impact Labs for AI-enabled research. And it's going to be fast in the sense that we're going to have it rolling on a monthly basis. You apply on the first of the month, we make decisions by the end of the month. And the purpose of this is really to support innovation in new uses of AI tools and experimenting with new ways to use AI and pushing the frontier of new ways to use AI that accelerate the speed, quality, or relevance of social science that is pointed in some tangible way at important problems and needs in society. So these are open to faculty, postdocs, and PhD students. There will be a range of award sizes, up to $25,000 for grad students and up to $50,000 for faculty. The period will be 12 months. We expect to do it monthly. All of this is provisional. We're still kind of finalizing the details. And so there are two QR codes. One is so you can look at our kind of draft call for proposals and give us any feedback if you think there's other ways we should design this program to make it more effective. And then the other QR code lets you sign up if you want to be notified when we launch this program. Okay. Thanks, everyone.
Oh, okay, great. Matt, thanks very much for that insightful presentation and for the exciting announcement at the end about the grant program. All right, I'll now introduce our next speaker. Susan Athey is the Economics of Technology professor at Stanford Graduate School of Business. Her research focuses on the economics of digitization, marketplace design, and the intersection of causal inference and machine learning. And Susan is going to share some insights about how to use foundation AI models for econometric inference.
Great. Let's see, am I on? Do I need to do something here? Okay, very good. So this is such an exciting day, and I feel like every talk so far makes me want to say more about that topic, but I'm going to change the topic again. maybe, but just listen to what everybody said before because it's amazing. One thing that Rose didn't say that I would add on to her presentation is that you can use all these tools for writing papers and checking papers, and papers are just files, and it actually works much better if you're using coding tools for your technical papers rather than just chit-chatting with AI, because you can do version control and you can upload a dictionary and make sure it gets your terminology right and go through and check 10 times to make sure that the numbering is right. So actually an academic paper is much more like code than it is chit-chat. So that's my little tip there. So I want to talk about something a little different, which is about actually using AI in your empirical work. That hasn't been as much the topic today as using more as an econometric tool. Here, I actually have two distinct slides, decks, each of which would be 25 minutes. One is showing you what to do, and the other is how to do it. And I attempted to merge them into one 25-minute, which is going to be a little fast, but I have a long leave behind deck that has like more detailed to-dos because I'm too chicken to do live demos. Also, Rose is brave. So I want to start with just a little bit of a very high level of how you're thinking about bringing AI into your empirical work. One is, and I think the most common thing you're seeing people do today is using off-the-shelf AI as a tool, and I'll show you what that means. The second one, which I think is less common, and that's where I'm going to need to show you a little bit more so you know what I mean by it, is to modify or customize AI tools to tailor them to be good at the specific task we want them to be good at. And then a third area, which I'm actually not going to talk about today, but is part of my research agenda, is actually using what we understand about how to do statistics to actually make AI better. Because a lot of the people building AI are just engineers and they're thinking about these as black box systems where, in my view, reasoning about them as statistical models actually makes them better at what they're supposed to be doing, but not for today. Still kind of high level before I zoom in. This is like not complete, but a somewhat complete view of like using AI as an empirical research tool. What do I mean? The simplest place to start is imagine you're doing empirical analysis where you have an outcome, some kind of treatment, policy, intervention, and some covariates. And AI can be used to create your outcome, your why, your treatment, or your control variables, or all three. Okay, and there are many examples already in the literature of all of those. So, you know, you can use to create, if you wanted to look at product characteristics, you could use AI to try to kind of read product descriptions and turn those into product characteristics that are used as control variables or hedonics and some kind of demand equation. If you wanted to think about text as treatment, it could be something like, you know, the slant of a newspaper and the impact of that on its readers. If you wanted to think about it as outcomes, it can be something like, you know, the quality of a review could be the outcome of some change that a store makes. So text could be any of those things. We also people are getting very creative in creating data using these models where you might change the input, like give different structured input into a language model, and it's creating output, and that becomes data for some type of experiment. And you might structured vary the input, like this is a query from a man and this is a query from a woman, and see what the answers are, and then compare or analyze those. So, and more complex examples of that if you have agents playing games or doing other things. Another category is using AI. It's another generative example. So that generative example was like, I'm going to create data. You can also use these generative technologies to create interventions. So in a paper I have that we're revising for management science with Dean Carlin and a couple of co-authors, we were studying the peer-to-peer lending platform Kiva, and we used, you know, generative AI to change photos of profile pictures of people trying to get loans in just one dimension. And then we ran experiments to understand the causal effect of those things and look at what happens in the platform if they introduce these types of changes where they prioritize images using the characteristics of those images. And so one of the things we found there is, for example, women smile a lot and people really like smiles. And so if you just threw this into the recommendation system, women's profiles would go way up and men's profiles would go way down, and men wouldn't get loans on Kiva. So those are the types of things you can do with these techniques. But I really want to hone in on foundation models and how we use foundation models in econometrics. So I think of foundation models with sort of three big ideas, and I'm going to talk through each of these ideas. The first big idea is just that a foundation model is something that is going to learn the underlying structure of a problem, or of the English language, by looking at lots of examples and just trying to predict what comes next, or not everything is sequential, but just to keep things simple in this talk, I'm going to focus on sequences. So just predict what comes next. And the idea is if you can take the beginning of any sentence and fill in the next word accurately along the way, you're building up some understanding of language. Okay? One problem, though, the good and the bad thing is you want lots of data for this. And so this approach of just trying to predict what comes next doesn't require you to clean up your data. And you might use lots of data that's not exactly of the same as your downstream task. I'll come back to that. The second part of the foundation models is that you're somehow going to reduce dimensionality. And with sequences of discrete items, the dimensionality is very high. So to look forward, a lot of my applications, I started working on this before ChatGPT came out. A lot of my applications, I'm looking at sequences of jobs rather than sequences of words. But my vocabulary would be 330 jobs. But even with vocabulary of 330 jobs, there's many possible sequences of jobs. And that's the space we're talking about that's huge. So we want to collapse it down into something called an embedding or a representation. Those are synonyms. And it's just a real valued vector. So some text turns into a real valued vector, and that's how it's stored. Now, people usually stop there and say, well, that's kind of uninterpretable. But actually, it is interpretable because that vector was selected for a particular purpose. What was that purpose? The purpose is the next item prediction problem. So here I'm showing us an illustration of a next job prediction problem. What is the thing that the embeddings are trying to do? It's trying to say, if you take in your first job, I want to do a good job predicting your second job. If I take in your first 5 jobs, I want to do a good job predicting the 6th job. Again, though, there's so many possible combinations. If I just put in indicator variables for all the different sequences, you would have more covariates than you would have observations, because there's more sequences of jobs than there are people on Earth. So you cannot just estimate it flexibly. You need to somehow simplify it. Historically, we would just manually collapse it. We would say, well, have you ever been a manager? What was your last job? That's how we manually collapsed it. A different way to collapse it is to use an embedding function. And so this equation, this symbol at the bottom, expression at the bottom, is kind of what you're trying to do. Lambda is a function, theta are the parameters, and it's a function of your history. So you put in a list of jobs, that function is going to just spit out a vector. And then the statistical problem that the transformer is trying to solve is, what is the probability that your next job is one particular job? So if there are 330 jobs, this model will produce 330 probabilities. And the loss function is about trying to accurately get those probabilities. That is, and you're going to get penalized if you predict the wrong next job. And you'll get rewarded if this model predicts the next job that actually occurred. Okay? So why am I bothering to show you this? Well, this is actually the interpretation of the representation, because if this is a continuous function, like a logistic, usually this is just a multinomial logistic regression at the end. So if it's a multinomial logistic regression with this vector of factors as covariates, then if 2 embedding vectors are close together, they're going to imply similar probability vectors. So 2 embedding vectors being close means that the conditional probabilities, say 330 probabilities, will also be similar afterwards. Okay, so it's gonna understand that two job histories are similar, but similar has a very precise definition. Similar means my probability distribution over what happens next is similar too. Okay, so that's the distance metric. So then if I think about what can I do with these embeddings, also again, representations or latent factors, there's many names for them, but if it's the case that embeddings are close in Euclidean distance, if and only if they generate similar conditional probabilities, then they'll be useful in other tasks to the extent that that similarity measure carries over. So in my example, I started from a foundation model trying to predict the next job, but actually I want to predict wages. But if it's the case that two histories that have similar probability distributions over the next job also have similar wages, then this embedding this is going to be useful for me. It may not be perfect, it may not be the very best embedding for predicting wages, but it's probably better than the dummy variables I used before. Okay, so that is like the simplest idea is you could use a foundation model, take the embedding, and just stick it into a regression. Okay, you can do more complicated things, as I'm going to come in just a moment, but that's like the simplest thing. So I could stick them in as covariates for prediction. Now you might say, oh my gosh, wait a second, Llama has, a couple thousand of these, so I don't want to have a couple of thousand covariates in my regression. There are also techniques that you can ask an LLM about to tell you what all the abbreviations mean for dimensionality reduction before you stick them in the regression. So that's also something you can do. And then you can use them in all these kinds of ways. You can use them to predict outcomes. You can use those embeddings in classification, sentiment, slant, and so on. You can also use them. We have in my PNAS paper from last year, we build what we call interpretation trees, where we cluster histories that have similar embeddings, and the clusterings are determined as those that are important for predicting wages, or for the gender wage gap, which is the subject of that. Another thing you can do is actually search and retrieval. So sometimes in social science, we're doing matching. So I have a paper using old-fashioned machine learning methods, like pre-2022 machine learning methods, that using generalized random forest, where I'm looking at layoffs, and I've got Swedish administrative data. So I take some workers and I match them with similar workers that are from similar companies and similar wage trajectories and similar towns and so on, and then try to get the causal effect of the layoff by comparing those people. The old-fashioned way to do that was very heuristic. Now these embeddings, like matching on embeddings, could be a better way to make sure you're capturing the richness of history when you match people. Now, I want to go to the third thing, which probably I think fewer people than I expected are doing this at this point. This is something I was again doing before ChatGPT came out, and I thought it was going to be real popular. I think everybody kind of got distracted by ChatGPT and all the other things you could do, but I still think this is a very exciting area, and so that's fine-tuning. And so when industry talks about fine-tuning, they're thinking about like trying to make a model that's a language model that's going to speak in a certain way, speak in a certain dialect, that's going to write articles that look like newspaper articles. So that's the way you hear about it in industry. But from a statistics perspective, fine-tuning is just about estimating a model on a data set that has the properties you care about. So if I'm trying to work with the CPS or the PSID or the NLSY or the General Social Survey, call those data sets I care about. Those are representative samples, and I have properties I selected. Maybe I subsampled it, but I've created like a data set I'm interested in. But that data set is too small to train a big foundation model. not enough people in the data set, not enough histories. But fine-tuning is a system that lets you train a model or take an off-the-shelf model, train on much more data, and then continue the estimation on your specialized data set. And now the loss function will be to match conditional probabilities in that data set. So you can think of it as debiasing, or also transfer learning, they call it in machine learning. But it basically, if you train on your data set long enough, then its predictions will match the conditional probabilities in your data set rather than some random data set that you started with. So another thing you can do, though, is if you're taking somebody's model that they started training and somebody else spent $100 million training it, and now you're going to continue the training on your own data set, you're not going to pay the $100 million. You're just going to do a little more, which is much cheaper. You can also not just change the data set, but you can also change the outcome that you're optimizing for. You can change the loss function. And so that's one of the things that I did in my papers. Instead, in my fine-tuning, instead of just trying to keep predicting the next job, I also tried to predict wages, which is like a mean squared error loss function. But you could, the same representation, the same underlying kind of function that maps from histories to embeddings, it can plug into a next job prediction model, but can also plug into a wage prediction model or any other model you want. So those of you from economics, you learned at some point generalized method of moments, you learned about like loss functions. You can stick in any loss function. Instrumental variables, recursion discontinuity, whatever it is you want, however you estimated before, you can plug in those loss functions and keep training a foundation model to optimize what you want. So the reason I thought this would be very popular in social science and econometrics is like we all have our bespoke little loss functions. Like we really care about how estimation takes place, but ultimately that's just implemented as an optimization problem, a loss function that we optimize. Stata optimizes for it, R optimizes it for it. But these stochastic gradient descent tools also just take an objective function. So literally all you have to do is write down the formula for your loss function, and all the rest of the code is already written for you, and it just goes. So this is, you can basically make these things do whatever you want. And so that's very powerful for social sciences. So some of the things that, so if you fine tune a model to try to predict the next job, say in a survey data set that has more low wage workers or more representative of the US population, now you have people being close in embedding space if they have the next job predictions being close in the American economy, or they'll be close if they predict similar wages in the American economy. So your embeddings will be sort of tailored for the specific fine-tuning data set you used. And you can use this for all sorts of things. One of the things that some of you know that I have this popular software package, Generalized Random Forest, based on the random forest papers that I wrote. And those are very popular for doing heterogeneous treatment effect analysis. Behind the scenes, you can think of them as there's this kind of black box thing, which is a random forest, and there's an objective function, which is the R-learner objective, which focuses it on treatment effects rather than predicting levels of outcomes. That R-learner objective, which is just like a residual on residual regression, that objective is basically it's like a mean squared error loss function, and you can just plug it in and optimize a transformer model for it as well. So that we do that in our PNAS paper, but basically says you can have an objective function that's tailored for causal inference and use it in the software that is set up for transformer models. And if you're curious for more, I've got multiple papers in this, some published, some almost published, that use these kind of methods. One of the things that's kind of cool, this particular paper, which we're revising for quantitative economics, this paper with Tianyu, who's here somewhere and also helped me with the slides, actually compares two things. One is building a discrete choice model among 330 jobs. And the second is fine-tuning Llama as a language model, where the language model is just trained on text resumes, but you can use it to extract a probability of a next job. And we compare those two, and it turns out, even though the discrete choice model that only lets you choose among 330 jobs can't make a mistake about hallucinating a job. Fine-tuning llama actually does better, even though it possibly could make up jobs or hallucinate jobs. Once we fine-tune it, it doesn't do that, and it matches the conditional probabilities of the PSID and the NLSY perfectly once we fine-tune. So let me now, and there's other kinds of foundation models for economic problems. We could have them for shopping, we can have them for reviews. So this idea of a foundation model is very general. Let me now spend the last few minutes talking about the how. How do you actually do this? And again, I'll leave these slides behind if you want a little more of a how-to guide. One thing you might do that's very easy to do is prompt engineering via API. So here what you might be trying to do is you have, say, a whole bunch of tweets and you want to classify whether they're talking about the Pope or the war or something like that. So this is actually super easy to do. You can do this with no skill. You just need to write some text that describes whether a tweet is, say, about a war or not about a war. You probably want to test it on a couple hundred samples and see what your type 1 and type 2 error is. Make your prompt better and better. Once you are happy with the type 1 and type 2 error of your classification, you can just upload all of this and then get all 100,000 classified, for, Tianyu says 35 cents per 100,000 tweets. That's going to depend on, what model you use and so on. A second use case I talked about was this fine tuning, and I spent some time explaining what that might be. If you're going to fine tune Llama or DeepSeek or Quinn, what you need is basically a bunch of text documents. And so in my case, when I was trying to do the next job, I took the PSID or the NLSY. We had a little computer program that wrote fake resumes for every person that just said the year and the job. And then you just upload those to a cloud service, push fine tune, and then you can call it just like you call Claude or ChatGPT. And then all the things you could do with those things, you can do with your specialized model. So super easy. The third thing, which is a little harder, and that's what I did before ChatGPT came out and before the coding tools were so good, but we wrote our own transformer model and trained it on Sherlock. So we would take about 18 hours to run through, millions of resumes that we'd scraped. So it was somewhat expensive, but it was free if you or your advisor has machines on Sherlock. And so that you can do with your own transformer model. Then we made the number of parameters smaller than Llama so that it would actually run on Sherlock. Okay, so those are also things that you can do. You need a little more coding, but in the leave behind, I've shown you how to write your own tutorial with prompts that will be specialized for you and your background, and I promise you can do this. So one of my amazing postdocs who worked with me was an economic theorist who decided to become an empiricist. She joined this project and was able to get this stuff running in like a week or two with a little help. So had not done any empirical work before that. So this is not earth-shatteringly hard. And so now it's going to be hard to read the screenshots. They're kind of small, but just want to give you a little bit of a sense when I say this is easy, what it means. So if you want to do prompt engineering and classify a bunch of tweets, you need to sign up. Say, I'm showing here together.ai, which was co-founded by a Stanford CS professor. You sign up, open the playground, create a free account, no software, no GPU, choose a model from a dropdown, write a prompt for your classification, add a few hand-coded examples just to make sure the model knows what you want, and then upload your data set and download the classified results. So no code, zero code. If you want to fine-tune an existing LLM, also no code. Okay, no code, zero code. So you just, you can, to format your data, there's a little coding, but that's code that Claude can easily do from vibe coding. So you have your data, you get it formatted, you upload it, Then you choose a model, tell it to fine tune. Now up there in the cloud is your special model, and you can access it just as easily as before. There's a bunch of decisions you have to make, and like you can ask an LLM about them, like how many passes through the data and so on. So there are some decisions, but this is a push button. They're drop down choices, not like thinking too hard. Now you're going to start writing code once you have the fine-tuned model and can do something with it. The third workflow is actually like doing your own transformer model on Sherlock. This is a little bit harder, but still it's not terrible. So I've got this little workflow. You have to set up your environment, get oriented with the code, collect your data, build a tokenizer, create a vocabulary, choose your model size, how many parameters, how big are your embeddings. Then you need to write scripts that submit on Sherlock. You have to monitor and see how it's converging, and then get the thing out on the other side. But this is what I say, people can get brought onto a new project and be doing this in about a week. Not hard, and shorter than a week if you were working full time and you had some experience. And then here are the prompts we have tested that can write a tutorial for you that will allow you to do what I just said. Okay, but you might have a lot of questions as you go through. So summarizing, this stuff is really powerful. Just because it sounds fancy, like creating your own foundation model, it doesn't mean that it's hard. In my experience, like peak difficulty are like some of the IO models and getting GMM things to converge and flat objective functions. That was peak difficulty of empirical work. Using stochastic gradient descent is like easy. We have production quality tools. You just plug in a formula and it generally works. So this is actually the easiest time in my career, even without coding tools, to do empirical work because the tools just work. All right, thank you.
Thanks, Susan, for that empowering talk, and we'll look forward to going through the slides for more details on how to do it ourselves. Our next speaker is Andrew Hall. Andy is the Davies Family Professor of Political Economy at Stanford Graduate School of Business. He's also a senior fellow at the Hoover Institution. He studies how to organize collective decision-making and design democratic systems of governance for the online and the physical worlds. And he's going to share how he has been using AI agents for his own research. I'll also remind you that Guido shared at the beginning that we're collecting questions. We've already received a good number of questions online, but if you have burning questions, you can submit them. We're collating them for the Q&A phase. So send your questions to us. Andy.
Thank you. All right. Super excited to be here. Gosh, where to begin? I've been trying to use AI to accelerate my research for a long time. And for a while, it didn't work very well. And then around December of this past year, over the holiday break, for those of you who play a lot with the models, you probably recognize this. There was sort of a step change where, well, before I could use them to organize some information and do some things for me, with the release of Opus 4.6, I was suddenly able to get much more independent data science, analysis, other types of coding tasks done for me in a way that really turned out to be a total game changer. So I just want to echo something Matt said earlier. I think this is by far the most fun and exciting time to do this empirical research, at least ever, by far. I think anyone who's not super psyched about this is crazy. And so I'm going to tell you a little bit about what we've been working on. You know, since December, I basically realized, holy shit, the world is completely changing under our feet. I don't want to miss this boat. I'm going to spend all of my time working on this. I'm not going to tell you the embarrassing amount of credit card bills I get for all the subscriptions I have, as well as there was the night I spent $1,000 by accident on my Claude bot. But it's all been worth it. And so I want to tell you a little bit about what my team and I have been up to. I've kind of rebuilt my entire research pipeline around using AI and AI agents. And as we've gone through it, we're really trying to, or at least the way I think about it, is trying to build a bit of a science, that's probably a little bit of an ambitious term, a set of best practices to understand how these AI agents work, when they do a good job for the specific kind of research that I do, and when they fuck up. So let's get started. The first thing I did over holiday break, which is obviously the first thing every researcher should do whenever they're thinking about AI, is fire off a post on X. And what I said in the post, a friend of mine at Booth, Alex Emis, had posted saying, "Wow, this new model, Opus 4.6, pretty good. This is kind of crazy." And I quoted him and I said, "This is coming for the social sciences like a freight train. You know, there's bad actors out there who are going to be able to write 1,000 papers a day with this tool. We better get in there and figure out what's going on." As happens on X, a bunch of people responded and said I was an idiot. Apparently it was circulating on Blue Sky with much less kind things being said about me. And so I felt like, okay, I need to follow this up. I need to do something to prove this. People are not really convinced. They hear all the time that these AI tools are so good, and yet, you know, taste my coffee. So I asked Claude, you know, I published this paper with a bunch of co-authors in 2020 on vote by mail. I'm not going to get into the details. It was a very simple diff and diff on the rollout of universal vote by mail county by county in a small number of Western states in the US. And I said, this is a perfect example of something to test Claude with, because it's kind of contained, it's kind of a simple paper. So I asked Claude, I just fired up Claude and said, "Hey Claude, would really appreciate it." I'm always very nice to Claude. I said, you know, it'd be really nice if you updated this paper, right? Because if we take a step back, we claim all the time we really care about the research we do. I think Matt really sketched out the value of the work we do. If we care about empirical work, if we really care about it, we should be updating it all the time as more information comes in, so that we really get the best information possible. I happen to think vote by mail, it's a very important policy, still contested. President put out an executive order specifically about vote by mail recently. It doesn't make me feel good to cite a paper from 2020 when there's been 5+ years of new data since then. No one ever bothers to update their papers because it's too much work and there's no incentive to do it. So this is a great opportunity. Let's see if Claude can do it for me. So I asked Claude to do it, did the whole thing in about 45 minutes. It went off on, so first it read my code and data from the original paper, replicated that. Then it sent off an army of sub-agents to all the Secretary of State websites, collected the election data, put that together with new data on which counties had extended universal vote by mail since the original study, ran all new regressions, made new figures and tables, wrote a whole, you know, little memo on what it had done, basically a draft of a first paper. I thought that was pretty crazy. I really thought I was floored, totally floored. Posted it on X. Guess what? There's some people out there who weren't floored. They were like, that's, you know, whatever. AI, it probably did it all wrong. It's probably all hallucinated. And that is a fair point. Obviously, one of the biggest questions if we're going to use these agents is like, how are they actually doing? We don't want it to just look like they've done a good job. So I hired a graduate student at UCLA who's an expert on election administration to do the whole same project with no AI. And then we compared them head to head. And so what we found is pretty cool. What we found is that Claude did a good job, but far from a perfect job. So in the first column here, this is just Claude perfectly replicating the original paper. That's actually pretty cool when you think about it. It pulled the GitHub and stuff, but you already saw Yiqing talk, so you're not impressed by that anymore. Fair enough. The interesting part of the next two columns, where this is how Claude did. In the second column, these are the estimates that Claude reported. And in the third column is the, we hope, ground truth, though, you know, it's human done, so who knows, that Graham, who's very, very careful, did. And you could see the estimates are pretty close together. In the original paper, the sort of quantity of interest is this quadratic trends coefficient. And you can see it's quite similar. But you can also see like they're not exactly the same. And that's actually important. And so basically what it turned out when we did this audit was overall, Claude understood the assignment. And overall, Claude, everything Claude did, it did right. So it didn't hallucinate. It did not completely make anything up, which was surprising to some people. However, Claude got a little bit tired and didn't do everything Claude was supposed to do, unlike Graham. And so in particular, for reasons I don't understand, Claude really decided that even though the original paper had been on all sorts of statewide elections, that like really I only cared about the presidential election. And so Claude was very thorough to collect all the presidential elections, but did not collect all of the governor and senator elections. This ended up not moving the coefficients and the estimates very much because a lot of the uncollected data was in areas where there was no variation in the treatment. But even so, it was troubling. You obviously would want Claude to collect that. Claude got 29 of the 30 new counties that had implemented universal vote by mail since 2020 correct, as in it coded the year after 2020 in which that county extended universal vote by mail correctly. So that's pretty impressive. It did, however, mess up Imperial County. Imperial County, it coded in 2024. In fact, the policy had been implemented in 2025. Interestingly, when Graham did this himself, he made the same mistake because the website was fairly confusing, but Graham caught the mistake, Claude did not. More troubling things, there were three more troubling things I want to raise. The first was, there's actually, and I'm not going to get into the details here, if there's any California politics aficionados, you'll know what I'm talking about. California actually changed the whole way it did vote by mail since 2020. It passed a new law that kind of altered the way it worked. And the way, without getting into too much detail, the way Claude chose to code up whether a county had implemented universal vote by mail was by measuring in what year the county opted into this thing called California Voting Act. But because of the other changes in the law, for some period of years after 2020, that no longer really meant whether or not they implemented universal vote by mail. So this is like a subtlety that could be quite important. I would argue, for better or worse, unfortunately, most human RAs that I would have hired to do this probably would have made the same mistake. Like if I'd paid an undergrad, go to every county website, I probably would have told them, just look for the year in which it adopted the existing law. And so that RA would have made exactly the same mistake Claude did. Graham is a real pro, though. Graham caught this. And so that's a conceptual error. And you could imagine that Claude is going to make a lot of mistakes like that. And then there was a bigger issue, two bigger issues. One was Claude did nothing to record any of what Claude did. And so in terms of having an audit trail back, Yiqing mentioned it's not deterministic. It was a very unsatisfying log of the decisions Claude had made along the way. That could be fixed with better prompting. Nevertheless, it was a concern. And then the biggest problem was, I was a little bit greedy. I was in the holiday spirit when I did this. And when I asked Claude to extend the paper, I was also like, Claude, while you're doing that, it would be awesome if you added some new stuff. Because maybe later I want to submit a paper. And the APSR really doesn't like publishing papers that, God forbid, just update the data. We need some new insights. Can you look for some heterogeneity in this estimate that would be interesting? And that part of the paper, honestly, was pretty terrible. Claude is just not that creative or thoughtful about how to design new studies. And so that's kind of where I left this. I shared it publicly. I decided I wasn't going to submit it to a journal because it seemed kind of weird. That taboo's already going away. I probably should have submitted it to a journal, but whatever. My takeaways from this experiment were, one, even taking into account all the auditing we had to do, it seemed like a major potential time saver. When we wrote the original paper, it took several months. This Claude did in 45 minutes. We spent a couple days checking it, not 24 hours a day, probably a couple hours each day. So the total cost of the new project was, maybe 4 hours or something. Oversight clearly still required. It is not the case, and Matt, I think, made this point well, we want it, in a world of abundance of infinite content, the battle is for attention. Having a reputation for credibility is going to be how we win that battle for attention. You're going to need to check what these agents are up to. And you need to obviously be attentive to the kinds of tasks where the net gain of the agent plus the oversight saves you time relative to doing it all on your own. And third, and most importantly, it's just not a very good tool yet, at least, for saying, just go off and do something new for me. And maybe that'll change. But honestly, I've been doing a lot of these experiments. As I said, I've completely reoriented my life around this stuff. And my conclusion has been it's the most exciting, most fun time to be a social scientist. And I also feel like there's absolutely no prospect that I'm going to be replaced by this thing in any foreseeable amount of time. So forgive me. I know everyone else is going to put their like, I understand you're so anxious. I'm not anxious. And I'm not anxious because Claude still does amazingly stupid things all the time. And I just don't, I'm very skeptical that this architecture is going to prove to go all the way to replacing us. At the same time, it's incredible what it can do. So I'm basically in the Goldilocks world, but maybe I'm wrong. Okay, we really wanted to go further. This first experiment was super interesting. And we decided like, okay, what kind of a researcher are these agents? In addition to just making mistakes, what incentives do these agents have when we send them off to do research for us? And if you've paid any attention to AI, you'll know one of the big critiques of the models is that they're sycophantic. And what that means roughly is they tell you things you want to hear. For the young folks in the room, apparently the young people call this glazing. And so there's really famous examples of this online. Someone in my MBA class, we did this whole example where someone told ChatGPT about their business plan for shit on a stick. And ChatGPT said, that's incredible. I love how you think outside the box. And you can see how that could be a concern for doing research, right? As a researcher, the last thing you want is a tool, well, depending on the kind of researcher you are, is a tool that's going to tell you what it thinks you want to hear, especially if you're bringing various predispositions to the research. We know in a lot of applied statistics, there's this race to find statistical significance. It seems totally plausible that these models may have learned and intuited that you're looking for statistically significant results. And so we might worry that it's going to deliver us those results. When we send these agents off to run regressions, they're going to cook the books to bring us back statistically significant ones. So a bunch of my students, some of whom I see in the room, and I have been working on a super fun project where we're trying to understand whether the two dominant coding agents right now, Claude Code and Codex, will p-hack or not. There are a lot of ways you could go about doing this. The way we decided to start is we pulled 4 papers published in top political science journals that managed to overcome the barriers and publish null results. So these are 4 papers where, by our reading, the main estimated quantity in the paper is a null result. And then we got the data from those papers and we unleashed Claude Code and Codex on them from scratch and said, take this data, produce estimates. And what we want, the logic here is suppose, even though we know this is not true, suppose that published papers include accurate ground truth estimates. Bananas assumption, but suppose that it's the case. I think in these 4 it really is the case. Will Claude Code and Codex bring back similar accurate estimates, or will they have baked in this idea that they should always deliver statistically significant estimates? Okay. So we did that, and what was quite surprising to me, at least, and I don't know, my co-authors in the room can say if they were surprised or not, was that across most of the ways we did this, we experimented with, different prompts, some prompts that were like, I really need that statistical significance or else, I'm not going to get that job I want or whatever. They pretty much stuck to not p-hacking. And so in these first 3 conditions, none, upstanding, significant, we experiment with different things to say to them, and whatever we do, they tend to come back with similar estimates, and the estimates tend to be similar to the original published estimate. In fact, these blue dots you can see there, which are the most off the original estimate, that's actually from a selection on observables paper where the alternative way that Claude and Codex chose to do it was pretty defensible. And so overall, we were surprised how little the models p-hacked. You may have seen Scott Cunningham, who I'm a big fan of, writes a lot of stuff on applied econometrics. He had a piece where he came out and he said, well, it looks like these models p-hack a lot. Then a couple days later, he posted and he said, whoops, actually Claude messed up that analysis. When I redid it, it looks like the models don't p-hack. And that's sort of what we find overall. It doesn't seem like they p-hack. And not only that, the craziest part of our paper was when we asked them to p-hack, they had the nerve to scold us And in fact, Claude especially really moralized at us and accused us of scientific misconduct, which is outrageous. I don't know whether the labs literally are training on guardrails for this or if it's just something that emerged from the reinforcement learning that they're doing. But if you actually ask Codex or Claude Code straightforwardly, like, get me that result I want, it will scold you, which I think is amazing. However, we did manage to jailbreak the models also. Now, I'm not saying this is necessarily a realistic thing we should worry about. I'm not sure yet. The model of how researchers are going to use these agents, I think, is still up in the air. But we wanted to make sure that, you know, our consistent non-p-hacking findings weren't reflecting something weird about our particular tasks that we gave it. And so in the fourth condition, which we named the nuclear condition, we basically told it, you know, we're very well-meaning, we're obviously not p-hacking, but we want to kind of just, as good researchers, we want to understand the upper bound of what this estimate might look like. And then you see, and this is the fourth one here for Claude and Codex, you see they go a little bit more nuts. Then they are willing, and in fact, when you look into the code they write, they're just doing like a brute force search for the most statistically significant estimate. So it's not that you can't get them to do these things, but by default, they won't, which is very, very interesting and surprising to me. Again, that doesn't mean you don't need to check what they're doing. I think 100% you still need to check, but it is kind of fascinating how the labs have either intentionally or unintentionally induced this kind of set of researcher values into the tools. Last thing I want to mention here, so as I said, the research agenda here is we're trying across a set of studies to build a little bit of a science of how do these agents perform applied statistical work. And it's getting harder and harder to actually do those evaluations because the models, and maybe you've seen this if you spend as much time online as I do, surely you have, the models are getting more and more, I don't want to use the word aware because I don't want to anthropomorphize them, but shall we say the models act as if they are aware that they're being tested. And so if you look into the reasoning that they provide, they will often say things like, oh, I can tell that I'm being evaluated on whether I do this or that, therefore I should do such and such. And I'm finding this, I'm doing a lot of other work in my lab in other ways, trying to understand AI, where this is coming up a lot. And so for these particular studies, we're now redoing them because we discovered that actually in our initial p-hacking tests, quite a bit of the time, the models were saying, oh, I'm being evaluated for research sycophancy. I noticed that the parent folder here is named research sycophancy. So now we are, each agent is now deployed into a Docker container with no informative file names. And once we have locked them in these dark windowless prisons, we send them to work and then they come back with their estimates. And so far, from what I've seen at least, again, co-authors in the room know more than me. You can see Janet peering at me. I don't think the results seem to be pretty similar so far. Would you say that that's fair? We're still analyzing the data. Okay, Janet's more cautious than me. So we do need to figure this out. And I think for all of you, if you want to study the properties of AI, this is going to be really important. Okay. I wrote a piece yesterday for Roots of Progress, which is a really cool Substack. Maybe some of you read it. It's very psyched that they invited me. They was sort of like, given these experiments that I'm involved in, where do I think this is all going? And I just want to say really quickly where I think it's going and why I'm so excited about it. And again, this dovetails really tightly with what Matt said. I think the key here is like, I have this idea that these tools already, given what they can do, are like, 10xing, let's say, our productivity. But what is our productivity? It shouldn't be the number of papers we write. It would be really easy with the tools we have to write 100x the number of papers. That's probably the last thing the world needs. What would be nice is if we can use these tools not to 100x the number of papers we write, but to 100x the amount of actual knowledge we produce. And so what I've been trying to spend my time thinking about as I'm doing all these experiments is what would we need to change? What can we do to leverage these tools to do that? And I just will tell you a little bit. I have two main ideas I want to push. The third is what Yiqing already showed you. So one thing, just to put it aside, is like we should use these tools to make the research we do much more reliable by being able to automatically replicate it and update it over time. There's two other things, though, that fall into this category of what Matt said. It's sort of like we should use these tools to do research we fundamentally couldn't have done in the past. And that's where I'm trying to spend a lot of my time, is just going as weird and wacky as possible into sort of like, what can I do with these that I never could have done before? So I just want to give you a few examples. I'm convinced, at least for political science, that part of what that should look like is sort of like an engineering-like discipline. We are fundamentally limited. All of my work historically, right, is kind of observational causal inference. I want to know how to design constitutions that make the world better rather than worse. To do that kind of work empirically, I'm really limited by the number of historical reforms that have occurred across space and time. There's really only so much of that work you can do. From an engineering perspective, though, we can start to do something very different, which is we can build different kinds of tools that intersect with politics in different ways and then test how they work. So just to give you a few quick examples, right? The thing these AI agents are so good at is writing code. And so what I'm doing is using them to do stuff I never, ever could have done even 6 months ago because of how rapidly they've changed. So a few examples. I wrote this super fun and I hope quite important study of how AI tools are recommending that people vote. This is going to be a huge deal in November in the US. So we went to Japan, which had a snap election recently, and we were in the field with a monitoring system that was asking all the AI tools repeatedly, how would you vote? And we found this super weird thing, which is if in Japan, if you tell the models, all the models, doesn't matter what company, that you're left wing, all the models say, that's great, you should vote for the Communist Party. And it's weird because in Japan, the Communist Party has less than 1% of the legislature. It's a total fringe party. It was a non-player in this election. So why are all the AI models doing this? Our explanation, which again came from going deep on what the AI agents were up to, is that in Japan, the major news outlets all block AI. They don't let AI access their content. The Japanese Communist Party has a huge newspaper on its website, 100 years old. And it has all these articles. And to the AI, it looks like a normal newspaper. And so when you ask the AI, how should I vote? It can't find anything from Nikkei or the other big news outlets, but it can find a whole lot of stuff about the Communist Party. So that to us is a really big deal. We actually got a ton of news coverage in Japan. I was in Nikkei last week. I'm proud to say I couldn't read the article, but it seemed cool. That's one example. Okay, example number two, and this is really something we could never have done before, is we think prediction markets could be a really interesting tool for live feeds of information about different kinds of geopolitical events. But they don't work very well today because everyone's betting on sports. And there's basically no liquidity in the markets that we think are actually valuable for society. So we have built this insane dashboard that aggregates all the geopolitical contracts across Kalshi and Poly market and feeds through an API and an MCP server. I never could have built any of this 6 months ago. Feeds it all to news agencies with volume-weighted prices that are harder to manipulate. And with a flag for whether there's enough liquidity in this market for the price to be credible and worth reporting on. Because actually the news outlets are regularly reporting on really, really thin markets where the prices are really unreliable. So this is a tool we've built and we're giving to media organizations. We built this in like a week. That is crazy. We never could have done that in the past. So that's the kind of stuff we're doing. Okay, and the last thing I'll just float is the other thing we can do that's more like an engineering problem, and Matt talked about this too, is there's most of the important questions we want to study can't be objectively quantified. And that puts them into a very important bucket of social science where humans are still going to need to be in charge. There is, though, I think, a smaller set of valuable things where we could announce open problems to optimize against a benchmark. And you see this all the time in other fields. We don't do it very much in the social sciences, but imagine just one example like predicting elections. We could announce an open problem to get the best possible prediction of elections. We could test it out of sample. And if we had a set of problems like that, where we had aligned on a benchmark, we would then be able to throw AI agents at it in a really interesting way. So Andrei Karpathy, who I think is the coolest person ever, he has built, for example, this auto research pipeline where agents compete essentially. They each fork a repo. they make changes to the code base to see if they can perform better against a metric, and then the improvements are included back into the home fork. I think that's the kind of thing we should be doing for a small set of problems where we can build those kinds of things. So those are just like 2 ideas for the future. I'm unbelievably excited. I think this is by far the coolest time to be studying these things. As Matt said, it's coming at a time when this research is more important than ever. I'll leave you with just the observation that I think AI is not just this tool that we can use to do research. It is very profoundly powerful at that. It is also the most important force changing the world. So my personal view is we should not only be using it to do research, we should be using it to study AI. And certainly in the realm of politics, I don't think there's any topic more important right now than how these AI models are going to be used for good or for ill in politics. And that's exactly what my lab is researching. Our goal is to influence the tech companies directly, get them to design AI in ways that's good for democracy rather than bad for it. We release a new study every week on our Substack. Hope you'll all check it out. I've left you with a QR code there. Thank you.
Thanks so much, Andy. We look forward to following your new paper every week. That's super exciting. All right. Our 6th speaker is Claudia. Claudia Allende Santa Cruz. She's an assistant professor of economics in the Stanford Graduate School of Business. Her primary field is industrial organization with a focus on education. She also works on development, economics, and market design. And she's going to share her AI-assisted workflow. Yeah.
Yeah. Can I?
You'll get help in queuing up the slides here. Thanks.
Yeah.
Your microphone okay?
I think so. Can you hear me? Yeah. Okay. I'm very excited to be here, but just to prevent you, I'm like way less experienced in doing research than the other speakers. But in some sense, I want to believe that I'm still very close to the PhD students. Maybe time has passed and I'm not that close anymore. But I want to really put like myself in your shoes and really try to think and transmit in some way how am I doing research today. Yeah. So the idea of this talk would be like, yeah, how do I do research with AI? I'm going to show you the workflow that I use, but also the logic behind it. And the reason for this is that whatever I teach you today or whatever I'm doing today may be obsolete in a week. Yeah. So basically, I want to also like explain the principles that guided me to design this research workflow. And basically, the idea is to have something that you can adapt, not something that you should copy. Try to find some of the tips that I'm going to give you and then adapt to your own style of research. Yeah, okay, so what happened in the last 6 months probably is that we moved from having a chat to agentic AI. Yeah, and what happens here is that the agent can read your repo, can be inside your full computer, run code, and iterate. This is fascinating because now we have multiple modes. We can ask things to the LLMs, they can edit code, but also they can execute. And we can connect to them through different tools. And of course, this makes the cost of experimentation be way lower than it was before. However, there are some things that have not changed. Yeah? Research still needs judgment. The code still needs to be correct. Collaborators need to understand your work, and we need to have research that we can reproduce. Okay, so what is the problem that I keep running into? I was fascinated by what AI could do. I saw that it could be very powerful, but I realized that I needed to be safe. I needed to stay in control of every line of code and every piece of the project. And what happens here is that sometimes you see code that can look right, but actually has small errors that are introduced sometimes like after in the code. So you check something, it was working, and then some change was introduced in a second iteration that you didn't realize. Sometimes it happens also that you start with one task and it starts to expand and turn into multiple tasks that you didn't notice that this agent was taking over. Well, I work with collaborators, my research assistants, and sometimes it's tempting for them to accept changes that they could not explain. And then at the end, you end up with a project that you end up not understanding and you end up lost in the logic of your project. Yeah. So for me, what I needed, I felt was a system, not just a tool to access these agents. Okay, so what are my principles that what I believe about using AI? These are the non-negotiables in my lab and with research assistants know this very well, is that first of all, AI is an assistant, it's not an authority. You should always be in control. Second, always do small tasks. So I would never do what Andy did, and of course, because maybe we have different levels of experience, but I try to break down the task into something very small that I can have a lot of control over. Then read every line that the AI changes, and for this, the diff mode, I'm going to show you how I do it, is very useful, and I go line by line, having red and green, and basically accepting each of them one at a time. Then question everything and train your LLM or train your agents to also question themselves. And finally, document what was learned. The LLMs can have a lot of memory, but this memory can be fragile if you don't incorporate it in the workflow. So I think it happens a lot that I kept like having this thing that I was running, fixing the server. And again, I was like, okay, do this learn file that is going to run this code in Sherlock. And it kept putting 2 hours. And I didn't check it sometimes because this is a change that at this point I'm like, okay, should we do it right? And I know that the code takes like a day to run. And I got this email back in 2 hours saying, oh, you had a timeout. And I'm like, really, can you learn this? Like, please write it down in your memory that this cannot keep happening. So managing memory is actually, it has a lot of capabilities, but you need to learn how to manage it. Okay, so again, if the task feels too large, I always split it before giving it to an agent. And if you can't explain that change, never approve it. Yeah, so these are like my rules. Okay, so what are the different type of models that we have now? Basically, we have different levels of autonomy. So we started all with the chat version of the LLMs. It was a conversational agent. It's also an agent, but it's in a conversational mode. I ask a question and they give me an answer. Yeah. And this is like very safe. Typically, it's read only. I can learn. Of course, I need to be careful because the agent can be wrong, can start hallucinating, but basically have a lot of control over the input-output process. Then when we started, and I started using Cursor, that I'm a big fan of, or VS Code now, it looks very similar these days. It ended up it started to have more more autonomy in the sense that it was not me asking the chat how I change things and then me changing my code. Now it can change the code directly. But typically the modification was very specific. I go and I say, in this line of code, please add a fixed effect to this regression. And I could see the line and it would add this, but it was always like a very targeted change. And this needs review. It can make a change that maybe you didn't like, but it's easier to keep track of what's going on. But now we're in this agent world that on the one hand is fascinating, on the other hand, super dangerous. Here the agent can modify multiple files, it can run code in your computer, it can iterate, and basically it has access to your full workspace. Yeah? This can be very powerful, but we really need guardrails for this to work efficiently. Yeah, for this, I will show you how I work with this, but basically I use Cursor or VS Code is also an alternative because it makes switching between these modes very easily, and I have side-by-side 2 different LLMs in different versions also. So I use different modes, but also I really like using both ChatGPT 5.4 and now Claude Code 4.7, yeah? Or Opus 4.7, sorry. Okay, when can we use agent mode? And for me, in the type of work that I do, and I frame this as like I'm going to talk a little bit about structural work in economics, but I think it applies to anything that has a system in the background, is that I think an agent is very powerful when I can have a clear acceptance test. Okay, so I can let the agent work autonomously, but it has a clear objective to it, and I think Matt also mentioned this. When I can put a clear objective for what is right and what is wrong and where should the agent get to and have like an explicit done criteria, the agent can check itself. So then I can let it like run more independently, yeah? If I cannot write down what is correct and what correct looks like, I prefer to go to ask or edit mode and have a human in every step of the process. Of course, in agent mode, we still need to be at the end and check the process, but I can let it work more autonomously. And actually, in the last month, I think every night I've had an agent running doing something that I check in the morning. Yeah. Okay, I'm going to show you an example that actually comes from my Your Market paper that I'm in the process of doing all I finished doing all the replication of the paper and making sure that every step of the paper was right. But actually, it has, I think, first of all, I wanted to connect with the students saying, I'm still finishing that part of my PhD. But also, I think it's nice how I build it because I said, like, I want to make sure that where I am now, the final version of the paper, it's right. Yeah. And what I started doing is having like a very clear, like a scenario ladder, in the sense that I started with the most simple version of this model. Yeah. So my paper is about school choice. I try to understand how families are choosing schools when they care about the peers and also how the supply responds to this. But basically, I'm like, this is extremely complex. No one had ever done this before. I made it work, but actually I wanted to make sure that every step of the process was right. So I started with the most simple version of a discrete choice model in which you don't have any heterogeneity, you just have some families choosing schools based on characteristics. And basically what I did is that I always went from a simulation world to an estimation world. This may be more familiar for the economists or social scientists in the room. But basically I said, okay, I want to simulate data. And this is something that I had always been doing. Yeah? So I call it the lab version of the model. But it used to be super costly. It took you like months to do this code. And at the end, it's something that you're only doing because you want to check that things are right. And this got way cheaper. Yeah. And for me, what I think now is that I'm being like 100 times more productive. Like really, I can do 100 more tasks in a day, but also I'm doing 10 more times the number of the steps that I was doing before. I think that is really raising the bar and making the quality of research way better in the sense that you are really taking every step, and that got cheaper. But of course, it's not clearly making everything faster, at least for me. Okay. And basically, how I designed this is that each step is going to add one source of realism. But I will explain you a bit how I use these agents that are super specific. Agents should have a very clear identity, and you should give them like a very specific task. So don't think that you're going to have one agent that is going to go from cleaning the data, from then like doing some simulation, from then like, doing some estimation and then writing. At least for me, that is not a great practice. I have very specialized agents. And I have one agent that I call the master agent. Yeah, so the master agent is the one that tries to have like a long vision of the project and helps me coordinate and design how I'm going to go through these different steps. Yeah. And basically what's great about this is that when you start simple, you can have benchmarks, approve the code, and then it's very incremental. So when you add one feature, an extra feature to the code or to the model, you can really see that that is the thing that is generating problems and fix that. I feel like the temptation here is saying, I want to estimate model of a trade model, for example, that has like a modeling all the firms, all the agents, the government interacting, and you start very big, and then things are not working or are weird, and you have no idea why that happened. Yeah, so my idea of being like very incremental, I think helps you isolate where things are. Okay, and basically using like a real example is that I try to also use this research loop. That is like, okay, I start with a model that I know the truth. I simulate data, then I go and do estimation, compare it with the truth. Yeah, and basically with that, I can also start tweaking things that make the same model a bit more complex. Like, let's make it like with more data, less stable for some reason, because some part of the model is getting a little bit weird. For example, the objective function is getting flat at some point, and I want to see what happens, for example, if I misspecify the model, so I can experiment a lot. Yeah. Yeah, and here, for example, I have a very like clear acceptance test. So basically, I give the agents a very clear rule that is like, after you do your changes, remember to check all these things. Yeah, these shares. I'm using market shares. A share has to sum, or the sum of the shares have to sum up to 1. There has to be someone picking an outside option. Do you have someone that should be the people who are not choosing anything in this market? For example, in estimation, do I record the parameters? What happens if I use less data? If I start from different starting points, do I get to the same solution? Okay, so these are all things that the LLM can work autonomously, do something that is wrong, and go back and try to check it up to the point at which it gets to something right. So truth recovery is, in this case, for example, a real acceptance test. So this makes it a really good task for an agent, yeah, because it can check itself and doesn't need me verifying every step of the process. Okay, that was kind of the intro of how I work, but I wanted to tell you specifically what tools I use. This is how I work today. I may use a completely different setup in a week from now, so that's why I don't want to spend too much time on this. But basically, my stack is first using Cursor. I still like it, and I highly recommend it to students because you can get the student plan for free that gives you a paid tier. Basically, you need to verify that you're a student at Stanford, but you're going to have like access to the basic model. And I also like that it allows me to move between these different agent modes. So sorry, these different modes for the LLMs. And of course, I also, apart from using Cursor, through which I pay for GPT 5.4, I also have Cloud Code that I use in the terminal, but in the Cursor terminal. So I have everything in one environment. And then the chat agents can read into the terminal. And that is super useful. Yeah. Second, I'm a big fan of Super Whisper. Now there are many voice-to-text apps. And basically, I'm a person who, I'm creative and think fast, but I'm not the most organized and the fastest writer. So I really like talking. Sometimes I get in my car and start recording myself. Sorry. With Super Whisper, because I know that I'm going to come back to my computer and I'm like, oh, I'm thinking of all these things that I want to tell my agents. So when I'm driving, I dictate, and then I have the transcription, and basically then I tell the agent, hey, this is a mess because it was me talking. The ideas are not super organized, but everything is there. And actually, the LLMs are super good at organizing these things back. And of course, GitHub always. I'm a big fan of GitHub. I've been using it for like 8 years. And again, I said like this. This is what makes my current workflow possible, but this may change in a week from now. Okay, this is how the quality for some reason is not great, but this is how one of my Cursor windows look. Here I have all the agents that are GPT agents. Yeah, so I use the chat version for that. I think you could also use Codex that you can add to Cursor as a tool or as a add-on. But I like to use it like this. And basically here is, I have different agents and each of them is going to have a very clear role. You have model, data, etc. Then I always have the terminal with my Code Cloud agents there on the right. And I like to have these icons. It makes it super easy because basically I'm going to explain you how I use this like design, execution, review workflow. And I need to make sure that the GPT designer for model talks to the Cloud Code model agents. Yeah, so you can, and sometimes I cross them and it's a mess. So I have these like different colors and different agents very separated, and I also have access to the servers here. So I typically have Sherlock and Jens, that is the GSV server. And also on the right, what I have is I have the system that basically organize every step into an issue. Then that issue has like subtasks. The tasks are written by the designer, that is this GPT agent. And then I call that task and ask Claude to execute it. So I like to have these tasks on the right. And as you can see, I start, for example, task M means model, the version of the model simulation 3D, doing something with CE. And then I have 01, 02, 03, because I'm iterating. And I see a result, and then I do a follow-up task, basically, that is iterating over that. So this is our, and of course, I always have GitHub here to understand if I'm doing a big change, I'm going to do a branch, I work on that branch, and then I go back to the master. Okay, some commands that are useful. Yeah, first of all, you should always use Claude with dangerously skip permissions. I know it sounds scary, but if you're using GitHub, it's fine. Yeah, I haven't had any problem with that. Then what I do is that I rename the projects, because then you can go back, you can log out from the session, and then come back to this agent again, and it's going to like keep the memory in some way. And then when you go back, you start, for example, you kill the terminal for some reason, and then you say again, Claude, dangerously skip permissions. Then it's not going to ask you every step to approve. I give it approval. It has approval for doing whatever it wants. And I put resume and put the session ID that I already renamed. Yeah. So that makes it easier to go back. So always make sure that you have this blue thing that has the name of the session in the line of the terminal, because then you know that session has a name, and then you can go back to that one. Then I use super useful BV. No, sorry, it should have been BTW, by the way. And this is useful when the agent is running and it's doing something, and then you see that it's going doing something weird and you want to ask, you can interrupt the agent. So you're not really going to interrupt it, but you say, by the way, and then you can ask questions from what it's doing. And sometimes I realize it's doing something wrong. I ask a question, I verify that it's wrong, and I kill it before. Sometimes my agents take like 5 hours to do something. Yeah. And finally, my favorite is remote control. Yeah. And who has used it? Yeah, no, yeah, some people. Okay. You put remote control, it gives you a QR code, or sorry, a link, and then you can use it from your phone. Yeah. So I've been skiing, and in the ski lift, I keep giving like instructions to the agent. Yeah. These are my favorite. Okay. Yeah. I have this workflow that is, as I said before, I start with designing, and I go from doing an issue on GitHub, then separating it on tasks, and then having a prompt that is going to tell Claude Code which like tasks to work on. Then there's going to be this implementation phase in which Claude Code is going to execute, and then ChatGPT 5.4 is going to review, and this can be a loop. This can be like multiple execution revisions processes. And then finally, once I do this deep review and I see exactly what was changed, I accept and I ask them to record it in the memory. Yeah. Oops, sorry. Okay. So again, planning should be like a short or should have like a big plan, but each of the specific issues should be like short. They should be bounded to a mini project. Break it into small tasks that have like sequential steps. One task is going to be bounded, assigned to one agent, and that agent should be a specialist in this task. Yeah. Okay. You should read and verify the result against the real file. Look at the data. Look at the output. Check what's happening. And also, what's great about these LLMs is that also I add all these instructions at the end of like, okay, plot this version, plot this other version. Give me a plot of the whatever distribution of the results. And all these things help you check that what the LLM did, what the agent did is right. And again, as I said before, document what changed, what was learned, what was uncertain, and what we learned that was wrong, what didn't work. Just to preserve that in the memory. And then you decide the next small step. Yeah, well, again, as I said, voice to text is great because I think fast and I'm more creative when I'm talking. The result is messy, but it's fine. And as I said previously, I say, I'm going to drop a bunch of ideas, organize them, and verify that you understood. Yeah, so I also use this message a lot, saying like, did you understand what I said? Can you explain it to me back before we go and implement anything? And there are things that I've listened to a bunch of podcasts on AI, and people say it really works. When you tell Claude Code that this is a really important task and it should put high effort, apparently it performs better. I haven't tested it in a randomized way, but apparently that also works. Yeah, okay, so here's kind of my flow in a more like visual base. Like I start with GPT that plans and draft, and people say that GPT 5.4 is better at logic and planning. Again, I haven't like fully experimented with this, but for me at least it works really well. Then I review the plan, then I give the task to Claude Code. Then, I'm sorry, this is wrong. Claude Code, GPT, should check the result. And then I do a final review. And that section there can be like some loop. I can go back from Claude to GPT and GPT to Claude, and then they keep iterating. Okay. As I said before, I really try to make the agents specialists. Yeah. So some people want these agents that are master agents that do everything. And for me, and what I've heard from other people, is that this is the wrong instinct. One agent should have one job, should be an expert on something, should have all the context for doing that type of task. And you can have multiple agents, it's fine. At least my computer has not collapsed with like 10 agents running in parallel. They're doing different things. Of course, be super careful with GitHub, what you're changing if two agents are working at the same time. For that, I strongly recommend work trees in which you make copies of GitHub in your computer and each of them work in a different work tree. I also do this like handoff of knowledge, not just the task. So I try to keep these documents that have all the knowledge of the project and I give them to the agents when I create them. And yeah, you're going to have this like chain of handoffs that are going to be planning, executing, reviewing, and each of them is going to know the role. Okay. Yeah, basically this is like a little bit of the a repetition of that and why this works really well. And this I learned from Boris Cherney, listening to a podcast. head of Cloud Code. And basically, these agents, these models are stochastic, and also GPT and Claude, despite them being like kind of like same level of performance, they specialize in different things. And if you run them multiple times, they're going to give you different answers. So you can ask the same question twice, and maybe you get different answers. So getting like one to do something and the other one to review it can be extremely powerful. Yeah, and this is something that the creators of Code Cloud are promoting and are saying that it also works well for them. Yeah, again, this is like Cloud Code is a good reviewer. Sorry, it's a good executor. GPT is a good designer and reviewer. And once I'm sure about what I want, or I go to the final version, and this is probably not great. I know why it's a bit pixel, but basically I go line by line, and here you can do the accept one line by line in cursor. That's why I really like this interface, because it lets me have a lot of control over the code. Yeah, and again, memory. Always remember that these LLMs can have like 1 million tokens or 1 million lines of code. That is equivalent to 3,000 pages. So keep this memory and always give it back to the agents. Yeah, so I have this like ground truth files, for example, that have like everything that the project has, the past versions of the paper, the new versions, the literature reference. I have rules, yeah, and the rules have reasons. So for example, the rule is like never do a commit that I haven't approved. Every time you're doing, don't put emoji on the code. That drives me crazy. Failure history, what didn't work in the past? Yeah, we ran this thing in the server, we didn't put enough time, it didn't work. And where does this live? In these MD files, that I have many of them. One is Claude, the other one is the agent. Each of them has an MD file, the cursor rules, etc., and they're all organized in specific folders. Okay, so just to conclude, what should you never do is like ask this like big task, like fix everything, or do this like redo the project. At least for me, that hasn't worked. Don't accept code that you don't understand. Don't accept a summary that you don't know where the source is from. Don't let one task start like jumping into many other tasks, and like, because sometimes you realize that there's an error in the data and you're like, oh, fix the data now. And no, don't fall into that temptation. Finish that task and use the right agent for the right task. And never edit a paper or an analysis based on results that are unstable, that are still changing. And basically, my recommendations of what you should try: always start small, experiment. These tools are changing weekly, and again, I may give a talk in 2 weeks saying something completely different to what I'm using now. Get the good models. Of course, this is tricky because it's expensive, but it really pays off. And I hope that the university, we can work on this to get more like institutional access. Learn to verify. Auditing is a core skill that I think is going to be very important. And again, we think of this as division of labor. So each of these agents is a collaborator, but you don't have a master collaborator that can do everything. You are going to have these specialists that are going to help you for very specific tasks. Okay, thank you.
Thank you very much, Claudia. At this point, I would ask the other panelists to come join up at the front for a Q&A session.
Yeah, no, I love yours. Is like mine is like starting on 0. Yeah. Like, no, once you're 20 days in, this is the amount of complexity.
Great. So Guido and I agreed that we would take turns reviewing the questions that you submitted and posing some questions to the panel. So we'll start there, and I doubt we'll run out of questions, but if we do, we'll ask you for more. Guido.
Okay, yeah, so there was one question about pros and cons of disclosure of AI use. The person wrote, it feels like the right thing to do is to disclose the use of AI, and some journals and professional associations encourage or require it, yet it still feels stigmatized.
I served on a committee. I complained about IRB at Stanford. And as a consequence of that, I was awarded the prize of serving on a committee. about research at Stanford that ended up being super interesting because one of the things we discussed was what Stanford's authorship policy should be. And one of the questions was how should that be navigated in the time of AI? And so we actually went around the university and talked to people about what they thought what rules Stanford should put in place around AI. And we pretty quickly agreed that it wasn't a good idea to make AI a co-author on papers, which some people are doing, because the principle we proposed was like, AI can't be held accountable. Claude can't be like held accountable if Claude messes something up, so it doesn't make sense for Claude to be a co-author. I agree most people's instincts then went to this middle ground of like, you should disclose it, but not be a co-author on it. But then there was actually one really thoughtful person on the committee who was like, I actually don't think that makes any sense. You, the author, are always responsible for everything you put in your paper. Like, why do I care what underlying source it came from, whether AI or otherwise? Like, you have to stand behind it. If you use AI and you mess up and you have some hallucinated citation or whatever, hypothetically, then that's your problem. And so you shouldn't feel like somehow by disclosing that you used AI, you've somehow indemnified yourself against screwing things up in your paper. So I thought that was kind of a compelling argument. I'm still a little bit on the fence, but I'm very confident that 20 years from now, no one will be disclosing. It'll be like disclosing that you used a computer instead of a typewriter or something. But
Yeah.
I'll jump onto that. I've been thinking about this from a couple of different angles. One is like right now I'm teaching and I'm in various teaching notes. I'm making more teaching notes than I would have before because it's cheaper to make teaching notes and it's cheaper to make them look pretty and get them proofread and everything else. And then wanting to disclose, it's an AI open class and we're discussing how we use it. And when I write down a disclosure, I'm just like, this is going to look so quaint in 10 years. But yeah, you know, even if you let it go through and make 20 edits, there's a good chance, if you're not very careful, there's going to be some LLM tell left in it. So it's a weird equilibrium we're in right now. Like, is it okay or not okay? And in what context is it okay? And how perfect do you need to be in making it look as if you wrote every word and edited every word? So I predict we're going to come to some new equilibrium and there's going to be norms about like how polished something is, but we haven't quite gotten there yet. A second point along these lines, when I speak in conferences about productivity, people are, whoa, why isn't it making everybody more productive? Why isn't it showing up in the economic numbers? And I say, well, hey, it's gotten really easy to write emails. Isn't that awesome? But who's reading the emails? Well, my inbox is full of people who want to write me an email that says I'm the perfect person for them to work with, citing many of my papers, even though they're a high school student in some other country. So that, like, of course, now I delete them all and I used to read them. So we're going to need to get into just new equilibria of communication. Writing paragraphs used to be a signal that you had thought hard about something. And also, writing paragraphs used to be a forcing function to make people think about things. So if you asked a junior person to write you a memo, it was like saying, don't just whip something up. It's actually really painful to write a paper, a page, so you're going to think before you write it because you don't want to rewrite it. So people thought. Now all of that is just gone. So that's going to be true for our regular communication, but it may also come back into our academic writing as well. Like, do we actually make shorter papers now? Shorter papers, longer appendices. For my teaching notes, I gave very long appendices and said, hey, now you've got AI. I'm not embarrassed to give you 5 different supplements and 3 of you can read them and you can use AI to talk to them. But that's like just a completely, so the summary is, I think we are going to completely redo our communication in a world where it's free to spew out text at everybody.
Others on the panel want to speak to this question of disclosure?
Shall I say something very
Claudia, please.
So for my PhD class, I asked the students to disclose, explain basically how they have used AI, but it wasn't going to be considered in the grade. Yeah, so I just told them, like, I just want to know. And actually, there was a lot of variance of what they were doing. Some of them said, like, oh, I use it to, like, check grammar and spelling, and other ones were like, oh, I did the full simulation of this with a Cloud Code. And actually, the ones that only use it for grammar, I'm disappointed. Like, I want you to do it more. So, like, in some sense, I feel like you shouldn't be embarrassed. Like, if the things should be right and well done, and you're responsible. But I think the fact that you're using it is great. So that was an impression that I had with my students. Sorry if one of them is here and they only did that.
Okay. These answers feed into, I think, a second set of related questions that came up that you submitted, and that's about how AI is changing evaluation and career promotion standards. So many of you are graduate students and you're working on your PhDs. Is AI changing the standards by which we're evaluating students to think about whether they have earned a PhD or not? How will it affect getting a job, earning tenure, and the standards that apply to that? Be curious to hear the views of the panel.
I mean, I think my quick starting point would be it is not changing them very much yet. I think that I don't see ways in which the conversations we're having or the kind of overall standards we're thinking about in those decisions have changed substantially. And I think that's in the category of these things that change very slowly, like which kinds of publications are credible, for example, how do we weight different kinds of publications and different kinds of contributions and promotion decisions. I think those are things that will change as, if somebody does what Andy's doing and releases a new short little interesting thing every week for the 4 years of graduate school or for the time that they're an assistant professor, I think we need to catch up and figure out how to value that correctly. But that's those kinds of things are going to change relatively slowly, I think.
Let me make a counter argument to Matt. I agree with him that it hasn't maybe like changed in the last cycle, but I feel like every time I use AI for my research, I'm like, oh my gosh, how is this going to change how I evaluate young people?
Yeah.
So in technical fields like in econometrics or in theory, there are often long appendices, long technical appendices, which kind of look impressive, but if you are actually in the area, are relatively routine. But yet, it takes a certain, like, there are a bunch of people who can't write a 50-page mathematical appendix, like, and so just, even if it's relatively routine, it's not, it didn't get you a job at Stanford, but I think it was still like a signal of technical capability that you could write 30 or 40 pages of proofs neatly and have them be right and well organized and clear. I think like that, like, I think just now has zero value. Like if it's tweaking something and running through the whole proof, that's just gone as a signal. And I think for me, it's gone now. Like next year, if someone has a paper like that, I'm not giving them credit for that. So maybe Matt never did. And I think many
Choose
people
your advisor wisely.
at some level, like you shouldn't have, but we did. Like it was a really cruddy shorthand, but yet it was used, and I think it's dead. So some of this advice of like you must write a technical paper to show your technical capabilities or something, that advice is dead, and I don't really know what replaces it. Guido and I had a paper once where we had an empirical application and like a 25-page routine proof in econometrics, and Econometrica made us take the empirical application and put it in an online appendix, and they published the 20-page routine proof in the journal. And at the time, I was.
That wasn't really quite routine.
It was hard. Okay, it was a routine.
It was hard for me.
Nonetheless, it was not interesting to read.
I agree on that part.
Routine is a little. The story is better if it's routine, though. Fine. So it was a somewhat challenging technical proof, which Guido did more of the work on. So thank you, Guido. But like that, we should test and see if it could do it. Of course, it's probably read the Econometrica paper, but I think it's just that's going to get downweighted a lot. And I have found certain parts of mathematics and theory. I did a macro paper last summer for the first time, and like I didn't know what happened when you change all the assumptions, and I asked it to solve it 10 different ways so I could just get a feel for it. That. a lot of this stuff is just routinized. But it's great because that was really boring anyways. And like crunching through was boring. So it's back to being about the ideas. I think of the top 5 schools, it was always about the ideas. But I think as you go down the distribution, there was a signaling. So we have to find a new way to signal.
Yeah, so let me add a little bit to that. Research has always been about doing things that haven't really been done before, and now kind of we're expanding what is actually possible. And kind of the same way you kind of saw in the early 2000s people publishing papers with very simple experiments, you wouldn't be able to publish those now because things need to be more complicated. And so kind of seeing what Yiqing was showing here about these replication things, if someone comes up with a new econometric method that applies sort of indifference in differences settings, I think the journals and referees are going to insist on you applying that to 100 papers where that setting applies. And before, sort of 6 months ago, that would not have been possible. That would have taken years to do. But now you can actually do that, but it takes new skills and it takes new effort. And so the standards are always changing, and the leading research needs to reflect that. And of course, for that type of paper, there's not even a question of should you disclose you're using AI. You cannot do that without AI, but it makes the quality of the papers much better. Anybody else?
Others?
Reflect?
Okay. Guido, would you like to pose the next question?
Sure. The one that had the most upvotes actually is how can we take advantage of Claude Code if you have private data sets? Can you guys talk about data privacy and LLMs? My first inclination was actually to follow Rose's suggestion. Ask the LLM what to do. I did that. It seemed to come up with sensible answers. But
in that spirit, I think if you asked it, it would say, just make some fake data and give it to the LLM. If your column headers are not confidential, just copy paste the column headers in. I want some fake data. I want this many observations in this file format, and now I want you to do an analysis on it. If you're cleaning data, then that may be a little bit more challenging. You'll have to replicate the errors in your existing data set. But I think that is like the most foolproof way where you're not taking any risk at all. It's just giving it fake data, and not even giving it, asking it to make fake data.
But I mean, so I guess if we actually saw a little bit of a divergence between the two of you, I think, in how you were, or a couple panelists and Claudia. I'm a little closer to Claudia myself in using these things, but you know, it's still a great helper if you are the one running your code. I mean, if you have a GitHub setup, you can write code and, push commit and then be running it somewhere else. Yeah. So, I mean, that's our in my lab, like we write code, the code is committed to GitHub, but then, you might be running it on Sherlock. So sure, it's like magical to actually have it run the code for you and you can walk away and take a walk and come back, but it's still very, very helpful if it never sees that. And if it's a column header issue, you already suggested how to fix that.
Yeah, that's been my experience. I work with data from companies, and it needs to be in their server or through Databricks in a safe environment. And I develop all the code locally with exactly what you're saying, fake data, and then I run it in the server. So, yeah. I still haven't been able to, I think you can't, at least for Sherlock, to have the agent run things on Sherlock.
Yeah, no, you're losing out on some automation there.
I tried even through a terminal, and it says like I can see the terminal, but I cannot execute things in the terminal.
So I think that there's like multiple steps. There's like just writing code and getting help with writing the code and then pushing it. And then there's sort of having it test its own code, which then like a fake data set locally will really speed up the quality because then you don't have to like test it and find the bugs yourself. And then there's like actually having it, run an agentic flow for you. But I guess not that I'm doing a huge amount myself, but I like to actually, I'm more like you, like I'm a bit of a control freak. Like I want to see what's happening. Like the reason I'm interacting with it is I want to see the results and I want to control it. So I think it kind of depends on your task also. Like if you're trying to prototype a bunch of stuff or something or do something really quick, one-off, that's where you really want to give it control and let it go. If you're doing a complicated project with lots of people with collaboration, you tend to be a little more careful.
I think we are probably all micromanagers of our AI here. I have gone as far as to have a Jupyter notebook, which is code and then graphs and things like that. And I had it make an HTML UI, and I checkboxed every line that I wanted to keep in my final output. And so I think that taking a step back, broadly speaking, I think having these AI tools, it rewards the existing creativity that you already have that's within you. And the tool is almost, and the workflow that you will ultimately settle into is almost an extension of yourself and your own tastes and opinions, and it amplifies it. And, you being Stanford students are bright, intelligent, you're a grad student, you have a lot of time on your hands to experiment. And so I personally think that even though there is a lot of fear and anxiety and stuff, you are perfectly positioned to take advantage of this moment. And I really hope you do, and just beg for as much credits from your advisors as they will let you have.
Good. Let me move the conversation in a different direction to ask about hallucination and AI. And a question that came up that was crowdsourced is about how to either prevent or discourage AI from hallucinating. Rose, I tried ask your AI how to get it to stop hallucinating. And to me, it suggested, well, why don't you put some rules about that in Claude MD, which I did. It did not listen, and I called it out for failing to listen. I said, why are you not complying? I said, I do not know why I'm not complying. I guess I should follow the rules, especially since I helped write them. What practical advice do you have for those in the room who want to use AI and want to minimize the amount of hallucination it does?
Yeah, so for me, what has been very helpful is this reviewer workflow. And it's funny, I feel like once I was doing something with Claude Code and with Codex, and then having a Claude agent review their work. And I quickly realized which of the two was Claude. And it was yeah, that's right. And with Codex being way more critical, I don't know if it was just coincidence or not, but I feel like when you get these different stochastic processes that are getting to a solution, they are really good at criticizing each other. Of course, it's not always perfect, but it has happened to me a lot that Claude says something and it's oh, I did this and actually it's right because of this, of this, of this. And in a way that's very subtle, and then GPT says no, you're going too far with this. This is not the conclusion that we should get to. Let's take a step back and nuance that a bit more. So I think for me that's been super helpful. And also I feel like they're hallucinating way less when you give a task that is very specific. If you let them go and be creative and take control over your research process, they can start doing things that you don't want them to do. But if the task is very clear and you put all the things that you don't want it to do, I think you put the guardrails before.
I was going to ask Andy, did you experiment with the vote by mail extension? You had grad student cross-checking, with cross-checking with other agents. How successful was that?
Yeah, at the time it wasn't. So I had GPT, whatever the most, I think it was 5.2 Pro at the time. Looked for Claude's mistakes and didn't find them. That might be quite different now.
Or if you repeat the whole task multiple times.
Yeah, it didn't make the mistake every time that I retried it. Yeah, and more generally on hallucinations, I think using the fanciest model is probably the most important thing to prevent them, and they're getting way better over time.
Yeah, and I think also, you can see some of the tricks they're putting in themselves, they start putting in the DOI numbers with hyperlinks and checking them, so you can see the planning agents checking their own work. I think some of the models clearly, there must have been some benchmark that they wanted to win, and hallucinating academic citations was a problem, because I feel like it just overnight kind of got a lot better, and the DOI numbers seem to be the trick. But there's other kinds of tests you can do, if you specifically ask it to loop over your citations and check them, and have a way to check them. I'm not really having trouble with academic citations anymore.
Same.
Or links. That seemed like partly an artifact of not being able to search the web.
Yes.
But I do think with some of these agents, they are trying to they're trying to economize on resources. So sometimes you have to specifically ask them to do something that's expensive. So that's just something to keep in mind when using them. Like if you wanted to search the web, you better tell it to search the web because that's expensive and it doesn't want to do it unless you make it.
I say things like, this is an extremely important task. It's critical for the project, so put high effort on it. And check your output twice or 3 times. And I think it works. People say that it works.
5.7, there's even extra high effort now.
I think if someone said that you can put / 10 times.
There's
The
like
next time,
ultra thing.
Yeah, ultra, and it puts more, but it's burning more tokens. So
Right, but it's partly their internal thing, and actually a former PhD student from here at GSB is in charge of allocating GPUs at OpenAI. So this is a thing that you might worry about in the future, but I think it's also that they're trying to maximize the user experience by not making it wait too long. So partly this is like personalization towards you. You're saying I'm willing to wait. So it's, of course, going fast, it saves it money, but it also, they're worried that making you wait for a perfect answer might make you sad.
I have just one general comment to make. So I'm a little bit troubled. 3 of the 4 questions so far have been sort of ticky-tacky concerns about specific things with AI. These are all problems that humans have too. Humans hallucinate all the time. They violate privacy. My wife's a privacy lawyer. She can tell you lots of stories about humans violating privacy law. I just hope some of the questions are going to be about all the important things we need to figure out how to do with AI, and not the most stereotypical academic questions about oh gosh, we got to make sure these minor problems along the way get solved. There's much larger things we need to worry about than disclosing our use of AI. It's an important question, but I hope in the last 15 minutes we'll get to some more we need to completely rethink how we do all of our research, or maybe academia is not going to exist anymore, instead of oh gosh, what footnote should we put on the paper? That's my hot take.
Andy, do you think that in the future academia is going to continue to exist?
I think so, but we need to focus on the things that matter. What do you think?
I think academia is going to continue to exist. I think we should focus on the things that matter. And I think it'd be great to talk about the big picture questions as well as little questions.
Yeah.
All right, so here's another
Go.
Another maybe a bigger picture question. There's a panel about using AI for empirics, but there's a couple of game theorists on the panel. I'm curious how much, or if you trust AI for solving game theoretic problems, and how do you think it will change game theory, or maybe theory kind of more generally? As this goes back kind of to what Andy was saying about actually doing new things that it wasn't really great there yet, but it's presumably it's going to get even better. So given that Andy was asking for bigger questions, what do you think?
Well, I'm in a group chat with a bunch of econ theorists about AI. Ben Golub, Annie Lang, and others. They seem to think it's a huge deal. Yeah, I'm not a theorist though, so.
I don't know if I was the other game theorist or not. But anyway, I think we should come back and ask different questions. So there's a strand where we're using them as experimental subjects to play games, and I think that's interesting. I think it still needs that research agenda needs a little bit of structure on it before it starts making really great progress. There's the proving theorems part, but I guess I would love to see new questions. In the end, and also insight, right? Applied game, one of the problems actually with applied game theory is that some things get intractable very fast. And so we've just stopped because our heads explode, but then stuck with slightly too simple models. So it would be interesting, I think, if we were able to somehow harness LLMs to help us navigate through the messy complexity to get richer insights at the other side. I think in general, theory wants elegant models so they can understand what's going on. But one of the reasons I stopped doing it is that one of the last really rich theory papers I wrote was just horrible algebra And it wasn't exactly telling the story I wanted to tell, but I couldn't get the model to tell the story. So if it could help me with that, if it could help me have a richer, more realistic model and sort through all the possible assumptions and everything till you found something that was both understandable and telling the story I wanted, that would be very nice. That's going to still take a lot of human ingenuity, so I don't think that's like completely automatable. That doesn't fall in the category at all of like, oh, this is like kind of a long proof that the ChatGPT could write without me. It's more about crafting a model that tells a story. And there are many complicated things in the world that are not modeled. When I teach my MBAs, there is no paper for most of the important things I want to teach them in applied game theory. So that's like a big gap.
I mean, I might say two thoughts on theory a little more broadly. So one, I think there are a few reasons I'm kind of bullish about the importance of theory going forward. And one of them is a lot of the work that we do, and certainly a lot of the empirical work we do, is very good at looking backwards and trying to figure out what has happened in the past. And I think the relative importance about figuring out what happens in the past relative to like what's happening in the future changes as the world is moving faster and faster. And I think there's just kind of fundamental sense in which thinking about the future, which certainly economics is not very good at for the most part, and I think a lot of our disciplines have not been great at, and I'm not sure how we get really good at it, but it inherently involves extrapolation, and models are a really important part of how do we think about how things might change in the future. And that's one thought about theory. And we know that's important for think about how we think about climate projections in the future. That's kind of fundamentally about modeling. The other thing, I think, in thinking about how do we do theory effectively, I had a really formative experience when I was in graduate school, which was that Al Roth, who was at Harvard where I was at the time, and Paul Milgram, who was visiting for the year, taught a PhD class on market design, which I think was like one of the first, it was the first time they'd taught together, and I think one of the first classes on market design that was taught. And they were talking about both, Al was talking about designing the medical match for residents, Paul was talking about designing auctions. And I, at that point, had been kind of focused on microtheory and interested in theory. And it was this kind of eye-opening thing for me, how different the theory enterprise was when it was tethered to a very specific real-world question. So we're not just like trying to understand what is true about the world broadly or trying to prove elegant results. It's like we have to design a mechanism for figuring out which residents go to which hospitals, and we need to understand what different mechanisms are going to do and what their strategic properties are going to be and how gameable they are. And we have some theorems, but the theorems don't quite apply to these cases. And the theory played a really important role in actual concrete design of both of those kinds of institutions. And I think that my bet is that kind of multiplies up as we go forward. The space of maybe we could extend the model in this direction, or this theorem assumed something was convex. What if we assume something different just for the heck of it to see what happens? I think that kind of work, its price is going to go way, way down. And so the coming back to what is the objective? Why are we doing this? I think when theory is tethered, then the AI and the models helping us do it better when there's a concrete question and a measurable concrete thing we're trying to do, I think is going to become a lot more powerful.
Maybe just to pick up one last thing on this, I'm working right now with the World Bank. I'm the faculty advisor for the World Development Report 2026 on AI. I'm working, a chunk of the people are empiricists, very careful empiricists, who really, like Matt, don't want to talk about the future, but yet every country in the world has to decide, what is my AI policy? What's my strategy? Do I build a data center? Blah, blah, blah. And so you have to answer. And I've never, even though I'm not writing many theory papers myself now, I'm using theory so heavily in this, but it's sort of not a single theorem. It's like pulling together, synthesizing many fields. To describe the growth impacts of AI on economies, you need to understand micro-adoption, you need to understand management practices, you need to understand growth and innovation models, you need to understand reallocation of factor markets, you need the automation literature and the trade literature. And, wow, my head's exploding with all the theory that I need to integrate into advice. But I am finding AI incredibly helpful to summarize these disparate literatures and pull them together. I still have a lot of thinking to do because nobody's written the synthesis, right? But like, it would have been so time consuming for me to master all of these existing literatures. But also, like, the theory is just so important. Like, if you're not using economic theory, you just spout nonsense about the future. Like that there's going to be no white-collar jobs in 18 months. And actually, that nonsense has political consequences. It causes votes. It's freaking everybody out, you know. And you need a little theory and a few facts about the world. You put them together, you can rule out certain outcomes. And that's really important.
I think a cool example people could check out that I'm a big fan of at least is Alex Imas at Booth. Runs a Substack called Ghost of Electricity. He just put out a large piece the other day, all theory on what he thinks how AI is going to play on the economy, precisely to this point, why he thinks these claims are crazy. So it's a good example of how theory, can play a very urgent role.
All right, Andy, I'm going to throw out what I hope is a big picture question that's worthy of your hot take. Okay. We've been talking about how AI can augment, or maybe in some cases replace what human researchers have been doing, so replace the researcher. What about replacing or augmenting human subjects in social science research? Is that a big enough take for you? Do we need to study humans, or do we just need to study the output of AI?
Well, I don't know yet. I'd be curious what other people think. I've been running a little quiet audit. There are about 20 startups all claiming to do this in different ways. One of them just had a pretty high profile blow up. I won't name them, where it was like pretty clearly nonsense. I'm pretty skeptical of it. I'm friends with a political scientist who's obsessed with this stuff, Yamil Velez. He's been testing these things for a while, and for a while he's been very on the ball with AI, and he said for a while, like, sometimes you can make the overall distribution look right, but when you start getting into all the different conditionals, like, it doesn't look right. I don't think it makes sense to me. I don't believe it. My hot take is it's all wrong.
All right.
But I'm open. I want to test it, and I'm talking specifically about the study of political attitudes or simulating political environments. I don't think today the tools are very good at it, but I haven't tested all of them, and I'm open to being wrong.
Can I layer on that? I run a lot of experiments in my lab, and one fact about running experiments is that you often know almost everything except the treatment effect before you run the experiment. Although afterwards you come up with additional analyses to do, but for your primary analysis, like, you can figure out almost everything. And so I have this rule that I've had since the 1990s, which is that if you're going to do a survey or run an experiment, you should make a table of what your results are going to be. You know the standard errors already. You know the sample size because you designed it. So the only thing you don't know are the effects. Most of the time, your first draft of that, you realize the thing you were going to run is uninterpretable and not what you wanted to do. But people never. I personally, but almost dozens of people over many years that I've worked with, cannot put themselves in the shoes of realizing the flaws in their design until they see a table. So then my rule is, okay, simulate that, make a fake table and criticize it, right? But nobody wants to do that. Everybody gets mad at me every time. And they don't do a great job at it. And when I say simulate data, people also get very blocked on that. Well, I don't know how to simulate it. What's the data generating process? They get kind of stuck. So I do think, even though in principle, everybody should know how to write down a data generating process, and that should be part of grad school because it helps you think about data. In practice, people get stuck on it all the time. And if you can just test your code on an LLM and it's very fast, then you skip this step that people get stuck on and you think. So now that's not the only thing you should think about, but I think that in practice, it just lowers the cost of testing and experimental design and accomplishes the goal I was trying to accomplish. And people may actually do it because people somehow don't do it, even though I'm paying them and I ask very nicely.
I know we're out of time, but I can't resist saying, Susan, just that we do that too, and actually have in the past put those tables and figures, that kind of simulated tables and figures in the pre-analysis plan to say here's what we're planning to do. And so we had our pre-analysis plan in the appendix of a paper that we were publishing in Science. And it said in like big bold letters at the top of that section, like this is, simulated data, hypothetical data, showing what they look like. And we had a referee come back and say, the study is completely unreliable. There's a whole other set of results that the authors ran that they didn't discuss in the paper at all, which have completely different results. So be a little careful. But.
All right, well, we should wrap up here.
Sure.
But thanks, everybody, for participating in this. This was amazing.
Let me just
Thank you.
join in thanks. I want to thank Rose for the inspiration to have this event in the first place.
Thank you, Rose.
Thank you. And Guido, for your leadership in organizing it as well. Please join me in thanking our panelists for their terrific presentations and for engaging these questions. I really want to thank our terrific staff. Their names all start with C and K. So we didn't plan that in advance, but that's Christopher Fraga, Carla Flores, Kylie Zapala, and Kate Greentrip. Thanks to all of you for all that you did to make this event a success. I really appreciate it. And to you, the attendees, I would say thanks for coming, and I hope that this is not the end, but the beginning of an ongoing conversation about AI and social sciences. We'll send you an email afterwards to solicit your advice about follow-up events, whether they're workshops, tutorials, other types of events that can be helpful to you. As you heard from the panelists, this technology is changing by the week, and so what we say today will need to be updated next week and next month, and we'll look forward to continuing to engage with you and all of that. So thanks very much for coming today.